For centuries, the human mind has chased the unknown, drawn toward the shadows that science can't quite explain. Beneath the surface of reason and discovery lie questions that refuse to be silenced, phenomena that defy every law we thought we understood. Why do some ancient structures align perfectly with stars invisible to the naked eye? What force moves ships and planes into oblivion without a trace? How can certain places distort time itself, where clocks fail and compasses spin endlessly? These are not stories from myths or legends. They are real events, documented, studied, and yet unresolved. Even the most brilliant scientists stand before them in quiet disbelief, caught between logic and something far greater. Tonight, we peel back the veil on the world's greatest enigmas, secrets buried beneath deserts, locked within oceans, and etched into the stones of forgotten civilizations. So sit back, relax, and open your mind, because what you're about to discover might just change the way you see reality itself. In the high desert of northern New Mexico, nestled against the base of the Sangre de Cristo Mountains, lies the quiet town of Taos, a place of striking beauty and eerie stillness. The landscape stretches outward in every direction, an expanse of pale dust and juniper, interrupted only by distant mesas and the silver ribbon of the Rio Grande cutting through stone. The air is crisp and dry, and at dusk, when the light turns the mountains crimson, a deep silence seems to settle over everything. Yet, for some who live here, that silence is an illusion. Beneath it, they claim, there's something else. A sound that shouldn't exist. They call it the hum. It's described as a low, persistent vibration, like the distant idling of a diesel engine or the faint pulse of machinery hidden underground. Some hear it most clearly at night when the desert is still. Others say it follows them indoors, humming softly through the walls, as if the earth itself were alive and restless. The phenomenon has been reported for decades, and though only a small percentage of the population can hear it, those who do describe it as inescapable, both physical and psychological. The first widespread reports emerged in the early 1990s when dozens of residents from Taos and its surrounding areas began complaining of an unexplained noise that no one else seemed able to detect. It wasn't loud, but it was constant, deep, rhythmic, and unnervingly regular. Some said it disrupted their sleep. Others experienced headaches, nausea, or anxiety. The local government, initially skeptical, eventually commissioned an acoustic investigation. Engineers and scientists from several laboratories came to Taos, equipped with sensitive microphones and vibration sensors. Their goal was simple: to find a measurable source. But nothing was found. The instruments picked up the usual background sounds of civilization: distant traffic, the faint hum of power lines, the wind against the desert floor, but nothing matching the low-frequency vibration people described. And yet, the witnesses remained adamant. They weren't imagining it. Some claimed the hum seemed to come from below, as if rising through the ground itself. In the absence of data, theories began to multiply. Some pointed to natural causes. Low-frequency sounds, known as infrasound, can be produced by geological processes, microseisms, shifting tectonic plates, even the resonance of wind moving through canyons. Others suggested more human explanations: distant machinery, underground pipelines, or high-voltage transmission lines that might generate subtle vibrations beyond normal hearing range. But none of these explanations ever fit perfectly. The hum didn't appear everywhere, nor did it affect everyone equally. Some residents could move just a few miles away and find relief. Others said it followed them, no matter where they went. Then came the stranger ideas. A few researchers speculated about military experiments, perhaps low-frequency radar or communication systems tested in remote regions of the American Southwest. There were whispers about secret underground installations or sonic technologies designed for submarine detection that might inadvertently affect civilians. Others ventured further into the speculative, that the hum might not be mechanical at all, but something biological, an interaction between the human body and subtle electromagnetic fields produced by the Earth itself. Still, none of these ideas were ever proven. The hum remained what it had always been, a mystery of perception and sound, half in the world, half in the mind. Psychologists began studying the phenomenon, noting that hum hearers often shared certain traits, a heightened sensitivity to background noise, perhaps even a form of auditory hyperawareness. Some proposed that the hum might be an auditory illusion amplified by stress or expectation, a kind of mass perception phenomenon triggered by suggestion. Yet that explanation, too, left gaps. It could not explain why so many reports came from one small region, or why some people could record subtle physical vibrations consistent with their experiences, while others heard nothing at all. In Taos today, the mystery still lingers. Newcomers sometimes dismiss it as legend until, late at night, lying awake in the still desert air, they begin to feel it too, a faint vibration just at the edge of hearing, like a presence beneath consciousness. Local artists have painted it. Musicians have tried to capture it. Scientists continue to debate whether it even exists in any measurable form. And yet, the people of Taos speak of it with a kind of quiet acceptance. The hum has become part of the landscape, as real and as unknowable as the mountains that rise above the town. Is it the echo of something mechanical, buried deep beneath the desert floor? A resonance of the planet itself, whispering through layers of stone? Or something we still lack the means to perceive, some hidden frequency of the world around us? The desert offers no answers, only the faint, endless vibration, and the uneasy feeling that perhaps, in the silence, we are not listening closely enough. From the quiet deserts of New Mexico, where the invisible hum of Taos vibrates beneath the silence, we travel now to a far colder landscape, one shrouded in mist, mountains, and mystery. Deep in central Norway lies the Hessdalen Valley, a remote stretch of wilderness where pine forests meet rolling hills and the night sky burns with northern light. But here, among the shadows of snow and the hum of distant rivers, another kind of light has been seen, one that defies every known explanation. They call them the Hessdalen Lights. For decades, glowing orbs have appeared in this valley, hovering, darting, and pulsing with a strange intelligence. They emerge without warning, floating above the frozen ground or streaking silently across the sky before vanishing into nothingness. Witnesses describe them as brilliant white, yellow, or sometimes even blue, intense enough to illuminate the snow, yet eerily silent, as if the air itself were holding its breath. The first reports date back to the early 1930s, but it was in the late 1970s and early 1980s that the phenomenon captured international attention. Dozens of locals began reporting strange luminous objects in the night sky. Some hovered for minutes at a time. Others shot across the horizon in impossible trajectories, zigzagging, stopping abruptly, then accelerating with blinding speed. To those who saw them, they were unlike anything known to science or aviation. By 1984, the mystery had drawn researchers from across Europe. Scientists, engineers, and students converged on the valley, setting up cameras and radar equipment in an effort to document the lights objectively. The result was the Hessdalen Project, a collaboration that would span decades. And for once, the cameras captured what witnesses had long described. The lights were real. Footage showed glowing spheres hovering motionless in the sky for over an hour. Spectral analysis revealed that these lights emitted energy in a way that did not match conventional sources, neither headlights nor aircraft, neither plasma from storms nor reflections from stars. Radar readings confirmed the presence of physical objects moving through the air. Yet no corresponding aircraft were detected, and no known natural process could account for their movement. What then could they be? Some scientists turned to natural explanations. One hypothesis suggested that the lights were the result of ionized dust, tiny particles becoming electrically charged and glowing as they drifted through the valley's unusual geology. Others proposed piezoelectric effects, where quartz-rich rocks under pressure could generate small electrical discharges that appear as floating orbs of light. In this view, the lights were not supernatural, but geological, a kind of living aurora of the Earth itself. Yet these explanations only went so far. The lights were too bright, too mobile, and too unpredictable. Some lingered for hours, hovering against the wind. Others accelerated in ways no dust or plasma should. The behavior seemed deliberate. As scientific explanations faltered, more speculative ideas began to surface. Some locals spoke of unknown atmospheric phenomena, energy forms not yet understood by modern physics. Others whispered of surveillance experiments or secret technologies tested in remote areas where few could observe them. And inevitably, there were those who saw in the Hessdalen Lights something extraterrestrial, an intelligent presence observing from above, its purpose unknown. In the decades since, the research has continued. Automated observatories now monitor the valley year-round, their instruments constantly scanning the skies. Data shows that the lights still appear, less frequently than before, but with the same haunting beauty. Photographs capture glowing orbs reflecting in the snow, sometimes splitting into smaller lights before disappearing altogether. And still, no single explanation fits. The Hessdalen Lights remain an enigma suspended between science and mystery. They are measurable, visible, and undeniably real, yet utterly resistant to classification. Like the Taos hum, they sit at the edge of understanding, where the physical world begins to blur into the unknown. Perhaps they are a natural phenomenon, born from the unique chemistry of this isolated valley. Perhaps they are an echo of something cosmic, energies drifting from beyond the Earth, briefly brushing against our perception. Or perhaps, as some quietly wonder, they are a mirror held up to human curiosity itself, a reminder that even in an age of satellites and science, the world still holds secrets that refuse to be named. On winter nights, when the sky clears and the snow glows blue beneath the moon, people still gather in the valley, watching and waiting. Sometimes they see nothing. Other times, a faint light will flicker across the horizon, hovering, pulsing, alive. And for a moment, it feels as though the universe is whispering back, what are these lights that glide through the silence of Hessdalen? Energy, illusion, or something beyond comprehension? The valley keeps its secrets, and the night, as always, keeps its watch. From the icy valleys of Norway, where the Hessdalen Lights drift silently through the night, our journey now leads us to a far harsher landscape, one defined not by cold, but by heat, emptiness, and time itself. Here, in the vast stillness of California's Death Valley, lies a place that seems almost beyond the reach of life, a place so dry that even sound feels thinner, swallowed by the desert air. It is called Racetrack Playa, a flat, cracked basin of hardened mud, rimmed by jagged mountains that glow gold and red beneath the desert sun. It is here that stones move. Massive rocks, some weighing hundreds of pounds, leave long, winding trails etched into the playa's surface, as though they've sailed across it. They drift in slow, graceful paths that curve, intersect, and sometimes reverse, like messages written by an invisible hand. yet no one has ever seen them move. The evidence lies only in their trails, faint, deliberate, and hauntingly precise. For decades, the sailing stones of Racetrack Playa have puzzled scientists, hikers, and dreamers alike. Early visitors to the region in the 1940s and 1950s reported the strange phenomenon with disbelief. Some thought the rocks were the result of human pranksters. Others suspected powerful winds, though how the wind could push such heavy stones across the flat ground without any visible assistance remained a mystery. The tracks themselves only deepened the enigma. Some ran straight for hundreds of feet. Others curved gently, as though following invisible currents. At times, two stones would appear to travel side by side, only for one to stop while the other continued onward. It was as if each had its own destination and its own will. Scientists began studying the Playa in earnest by the 1970s. They measured the stones, documented their movements, and installed markers to detect subtle shifts. But the desert offered no easy answers. For years, researchers returned only to find new trails, proof that the rocks had moved again, quietly, while no one was watching. Then came the first serious hypotheses. Some suggested that rare rainstorms might coat the Playa with a thin layer of water, turning the hard clay into slick mud. Under these conditions, perhaps a strong wind could push the stones forward. Others proposed that sheets of ice might form overnight, locking the rocks in place. As the sun rose and the ice melted, the rocks could glide slowly across the surface, leaving their elegant trails behind. These explanations sounded reasonable, but they had one flaw. No one had ever witnessed the process. For decades, the stones moved unseen, always in secret, as though the desert refused to reveal its method. It wasn't until 2014 that researchers, using time-lapse cameras and GPS sensors, finally captured the phenomenon in motion. To their astonishment, the rocks indeed moved, very slowly, just a few inches per second, pushed by light winds across a thin layer of ice floating atop a film of meltwater. The process, though rare, was now observable. Nature's quiet choreography, guided by perfect balance between temperature, wind, and water. And yet, even with this discovery, the mystery didn't truly end, because the explanation raised as many questions as it answered. Why does this delicate set of conditions occur only here, and so rarely? Why do some rocks move while others remain still, even when side by side? And why, in a landscape known for its heat and dryness, do these fleeting sheets of ice form at all? Some geologists point to the Playa's unique microclimate, its subtle elevation, and the way cold air pools overnight. Others suggest the terrain holds something more unusual, perhaps electromagnetic variations or small differences in the clay's composition that influence movement. And beyond science, whispers persist of stranger forces, geomagnetic anomalies, or even ancient energy lines running through the valley, guiding the stones in patterns we do not yet recognize. Standing in the center of Racetrack Playa, it's easy to understand why such speculation endures. The land itself feels timeless, almost sacred. The wind carries a low, constant hum, and the mountains rise like silent witnesses. You can see the stones scattered across the vast expanse, their trails stretching behind them like footprints of forgotten travelers. In that stillness, it feels impossible that these objects, solid, immovable, could ever have glided across the Earth. And yet, they have. Even with modern data, the sailing stones continue to challenge our understanding of motion, environment, and time. Their movement reminds us that the planet is far more dynamic and mysterious than we often realize. It's a phenomenon that exists at the fragile intersection of chaos and order, visible only when the world aligns in perfect silence. Perhaps the desert is speaking in its own language, one written not in words, but in motion across the dust. Or perhaps, like so many of nature's secrets, it simply asks us to observe, to question, and to wonder. Because in the heart of Death Valley, where nothing should move at all, the stones still sail, and no one can fully explain why. From the sun-scorched plains of Death Valley, where stones glide mysteriously across the desert floor, we now travel halfway around the world, to the rugged heart of South Africa. Here, beneath the dusty red hills near the town of Klerksdorp, miners have unearthed objects so small, so simple, and yet so profoundly puzzling that they've sparked decades of debate among geologists, archaeologists, and theorists alike. They are known as the Klerksdorp Spheres, tiny metallic-looking orbs, perfectly shaped and astonishingly old. Most are no larger than a walnut, smooth to the touch, and marked with fine parallel grooves that encircle their circumference. Some are made of a hard bluish mineral. Others appear reddish-brown or dark gray, as though cast from an unknown alloy. When first discovered, they were found embedded deep within layers of pyrophyllite, rock formations estimated to be around 2.8 billion years old. That number alone stopped scientists in their tracks. How could something so precise, so geometrically perfect, exist within rock that predates the rise of complex life itself? The miners who first unearthed them in the 1970s didn't think much of the find, at first. The spheres rolled easily across their palms, oddly symmetrical and strangely heavy for their size. But soon, word began to spread beyond the mines. Local newspapers published stories about metallic spheres older than humankind, and curiosity grew. Were these simply natural formations, or artifacts left behind by something or someone from a forgotten age? When geologists from the Klerksdorp Museum examined the spheres, they confirmed their extraordinary age, but offered a more conventional explanation. The objects, they said, were likely concretions, natural mineral formations created when sediments accumulate around a central core and solidify over immense spans of time. Under specific geological conditions, these concretions can form with surprising regularity, even symmetry. And yet, not all the spheres fit neatly into that theory. Some appeared to be made of a nickel-steel composite, resistant to corrosion, and unlike any natural mineral found in the surrounding rock. Others exhibited a near-perfect balance, so much so that early measurements claimed they were almost identical in shape and mass, varying by less than 1/1000th of an inch. A few were said to spin slightly when placed on a flat surface, as though magnetically charged or internally weighted. Skeptics dismissed many of these claims, pointing out that erosion, pressure, and mineral crystallization could easily produce such coincidences. But the unease remained. How could natural forces carve so many perfectly rounded spheres, some with delicate grooves running precisely around their centers? And if they were natural, why were they found only in a few very specific layers of ancient rock, and nowhere else? As the debate continued, the Klerksdorp spheres took on a life of their own, moving beyond geology and into the realm of mystery. Alternative researchers began to speculate that the spheres might be out-of-place artifacts, evidence of an advanced civilization that existed on Earth long before the rise of modern humanity. Some went even further, suggesting they could be remnants of extraterrestrial technology, or fragments of meteorites engineered by unknown intelligence billions of years ago. Of course, such ideas remain far beyond what science can confirm. The mainstream explanation, slow, patient geology, still holds the strongest footing. Yet, even among scientists, the mystery has not entirely faded. In 1984, a South African geologist named Roelf Marx noted that one particular sphere displayed an internal structure unlike any he had seen. It appeared to have a fibrous texture inside, almost like strands or filaments embedded within. Another, when cut open, revealed a lighter core surrounded by a darker shell, patterns that seemed almost too deliberate for chance. Today, the Klerksdorp Spheres are kept in the museum for public viewing. Visitors often stare at them in silence, their polished surfaces gleaming under the glass display. They are small enough to fit in a child's hand, yet heavy with implication, echoes of a time long before the human story began. So what are they truly? Geological oddities sculpted by time and pressure? Or silent remnants of something far older, whispering of lost epochs and forgotten technologies? When you look at them, those smooth, grooved, perfect forms, it's difficult not to feel a sense of unease. They seem deliberate, intentional, as though they were made for something. But by whom? By what? Perhaps the Earth itself shaped them, its deep processes capable of more beauty and mystery than we yet understand. Or perhaps they hint at a chapter of prehistory still buried beneath our feet, waiting for rediscovery. Whatever their origin, the Klerksdorp Spheres remind us that even in the most ordinary rock, time can conceal the extraordinary, and that the line between what is natural and what is made may not always be as clear as we imagine. In the quiet halls of the museum, they rest, tiny, perfect enigmas from a world we have only begun to glimpse. And somewhere, deep in the strata of ancient stone, the Earth still keeps its secrets, waiting. From the ancient mines of South Africa, where perfectly rounded spheres whisper of a forgotten past, we now descend, literally, into one of the most isolated and inhospitable places on Earth. Far beneath the frozen surface of Antarctica, sealed away under nearly 4 kilometers of solid ice, lies a hidden world that has remained untouched for millions of years. It is called Lake Vostok, and what scientists discovered there has challenged our understanding of life itself. Imagine a body of water the size of Lake Ontario, completely buried, invisible, and locked beneath the Antarctic ice sheet. Above it, the temperature never rises above -60 degrees Celsius. Winds howl across a desert of snow where no living creature can survive for long. And yet, deep below that frozen silence, this lake has been sealed off from the surface for an estimated 15 million years. A self-contained ecosystem cut off from sunlight, atmosphere, and the world we know. When Soviet scientists first detected the presence of Lake Vostok in the 1970s, using radar and seismic measurements, the idea seemed almost impossible. How could liquid water exist under such immense pressure and cold? The answer lay in the planet's own heat, geothermal warmth rising from beneath the Earth's crust, just enough to keep the lake from freezing entirely. For decades, it remained a scientific curiosity, an inaccessible mystery buried under miles of ice. But in 2012, after more than 30 years of drilling, Russian researchers finally broke through to the surface of the hidden lake. What they found has since become one of the most intriguing and controversial scientific puzzles of our time. Samples taken from the frozen layer above the lake revealed traces of microbial life, tiny, resilient organisms that appeared to defy the rules of biology. They were unlike anything seen before, surviving in complete darkness, with no access to oxygen or organic nutrients. Some sequences of their DNA did not match any known species on Earth. How could life persist in such an extreme environment? Mainstream explanations suggest that these microbes might be ancient lineages, descendants of organisms that adapted to the lake's isolation millions of years ago. In the absence of sunlight, they could be feeding on minerals or chemicals from the rocks below, drawing energy from hydrogen, sulfur, or iron rather than from photosynthesis. Such life forms, if confirmed, would offer a glimpse into the earliest forms of biology on Earth, organisms that existed before oxygen filled the atmosphere. But as with many great discoveries, certainty soon gave way to controversy. Some scientists argued that the microbes found were simply contaminants, introduced by the drilling process rather than native to the lake itself. The samples, they claimed, had been tainted by kerosene and antifreeze used to prevent the borehole from freezing shut. Others insisted that the genetic data were genuine, pointing to unusual DNA fragments that hinted at an ecosystem beyond the reach of contamination. Then came a more startling revelation. Among the thousands of genetic sequences recovered, some researchers reported finding fragments that matched no known domain of life, neither bacteria, nor archaea, nor eukaryote. If accurate, this could suggest the existence of a form of biology completely alien to anything we've encountered, a fourth domain of life evolving in secret beneath the ice. Naturally, such claims drew skepticism. Critics argued that sequencing errors, contamination, or misinterpretation could easily explain the anomalies. But others saw the possibility of something profound, that Lake Vostok might harbor a biological system unlike any other on Earth, a living relic from a time before multicellular life began, or even a model for what life might look like on other icy worlds. Indeed, the implications extend far beyond Antarctica. Scientists studying Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, point to Lake Vostok as an earthly analog. Proof that life can exist in dark, pressurized oceans sealed beneath ice. If microbes thrive in the depths of Antarctica, could similar organisms be surviving beneath the frozen crusts of distant moons, waiting for us to find them? Still, the mystery remains. Access to Lake Vostok is limited. Each new drilling attempt risks contamination or destabilization of the fragile ecosystem below. Much of what lies within that hidden lake remains unseen, unmeasured, and unknown. What might we discover if we could explore it directly? A camera lowered into the black water, a probe drifting through its alien darkness? Would we find simple bacteria clinging to ancient rock? Or complex, unseen forms of life evolved in complete isolation since the dawn of time? For now, Lake Vostok remains sealed once more, its waters hidden beneath miles of glacial ice. It exists as a mirror of mystery, an untouched world beneath our feet, reminding us that even on our own planet, vast and ancient realms remain unexplored. Perhaps, somewhere in that frozen abyss, life has continued to evolve, patiently, quietly, in a darkness that has never known the light of the sun. And if so, what other secrets might still be waiting beneath the ice, beyond the reach of human eyes? From the frozen stillness of Antarctica's buried lakes, where unseen microbes may have survived in isolation for millions of years, our journey now descends into another hidden world, one not beneath ice, but beneath the ocean itself. Far from any shore, deep within the eastern Pacific, lies a chasm so vast and ancient that it seems to lead directly into the heart of the planet. It is called the Hess Deep Rift, a place few have ever seen, and even fewer truly understand. At first glance, the ocean above it appears deceptively calm. Gentle swells roll across a stretch of open water near the Galapagos Islands. But below, more than 3 kilometers beneath the surface, the seafloor splits apart into a raw wound of stone and molten fire. The Hess Deep Rift sits where the Pacific Plate and Cocos Plate pull away from one another, exposing the inner layers of Earth's crust in a way found almost nowhere else. It is, in many ways, a natural laboratory, a rare living cross-section of the planet's geological anatomy. Discovered in the 1950s during surveys of the East Pacific Rise, this underwater canyon stretches for nearly 20 kilometers, plunging deep into the Earth's crust. Scientists were astonished by what they found there: sheer walls of solidified magma, shimmering hydrothermal vents, and vast deposits of metal-rich rock unlike anything found on land. But even more extraordinary were the unexpected formations and chemical signatures that seemed to defy conventional geology. Here, within this abyss, researchers have uncovered rocks that should have remained buried miles below the surface. Gabbros and peridotite, materials from the Earth's mantle itself, somehow thrust upward and exposed to the ocean floor. According to standard plate tectonics, such a process should take tens of millions of years and immense geological pressure. Yet at Hess Deep, these layers appear almost freshly revealed, as though the planet's interior had been peeled open overnight. What kind of force could tear the Earth so deeply, so violently, and so precisely? Mainstream geology suggests that the Hess Deep Rift is a product of divergent tectonic motion, where crustal plates drift apart and magma rises to fill the gap. Over time, this process forms new oceanic crust, continuously renewing the seafloor. But some findings challenge the simplicity of that explanation. Certain mineral formations, for instance, display patterns suggesting intense magnetic anomalies, zones where the polarity of Earth's magnetic field seems to twist and reverse abruptly. Others contain rare chemical combinations that do not match surrounding rock, as if they originated from a different part of the planet entirely. These peculiarities have led to deeper questions. Could the Hess Deep Rift represent more than just a tectonic boundary? Might it be a kind of geological conduit, a channel where materials from the mantle interact directly with the oceans in ways still unknown? Some researchers speculate that the rift could host unique forms of microbial life, sustained not by sunlight, but by the chemical reactions between water and freshly exposed rock. Indeed, hydrothermal vents in nearby regions are known to support entire ecosystems of extremophiles, organisms that thrive in conditions of intense heat, pressure, and toxicity. If such life exists within the Hess Deep Rift, it could hold clues to how life first began on Earth, and perhaps how it might exist elsewhere in the cosmos. But there are those who look at Hess Deep and see something more enigmatic. The symmetry of its fracture lines, the unusual distribution of minerals, even the apparent smoothness of certain exposed walls have led a few to wonder if natural processes alone could account for its formation. Some fringe theorists have proposed that the rift might not merely be the product of shifting plates, but the remnant of an ancient impact or the scar of an unknown event deep within the Earth's crust. There is, of course, no conclusive evidence for such ideas, yet the Hess Deep Rift continues to challenge scientists, yielding data that sometimes raise more questions than they answer. Each new expedition brings back samples and imagery that hint at an even deeper complexity, suggesting that we still understand only fragments of the forces shaping our planet from within. Beneath the crushing darkness of the Pacific, the rift remains alive. New rock forms, old crust collapses, and minerals unseen by human eyes for eons are exposed to the light of submersible lamps for the first time. The Earth, it seems, is not a stable body at all, but a breathing, shifting organism, constantly remaking itself from the inside out. What other secrets might lie within this underwater scar? Could the Hess Deep Rift reveal more than the structure of our planet, perhaps even the origins of its life, or the mechanisms that sustain it? For now, it remains a silent wound at the bottom of the world, its mysteries sealed within stone and darkness, waiting for those brave enough to descend into the deep. From the fractured depths of the Hess Deep Rift, where molten rock rises and the planet reveals its inner workings, we turn our gaze upward, to something less visible but equally powerful, a force that surrounds the Earth itself. It cannot be touched, yet it shields every living thing from cosmic destruction. It moves in silence, yet its power shapes compasses, guides migrations, and even alters the flow of the planet's core. This unseen guardian is Earth's magnetic field, a vast, invisible ocean of energy. But beneath its steady surface lies one of the most perplexing mysteries in all of science: the magnetic reversal. Imagine standing on a barren volcanic plain, perhaps in Iceland or the Hawaiian Islands, where dark basaltic rock stretches in every direction. These stones, though silent, are like pages in a planetary diary. When they cooled from molten lava, they locked within them a record of Earth's magnetic direction, just as it existed in that moment. And what those rocks reveal is astonishing. Time and again, across millions of years, the magnetic poles have flipped. North became south, and south became north. This isn't a theory, it's a fact written in stone. The ocean floor itself bears the proof. Across the mid-Atlantic ridge, alternating stripes of magnetized rock show a precise pattern of polarity reversals, spreading out symmetrically on both sides like geological fingerprints. It is as though the planet's magnetic heart has changed rhythm over and over again. But how and why? Scientists know that Earth's magnetic field is generated by the movement of molten iron within the outer core, some 3,000 kilometers beneath our feet. These swirling currents of metal act like a planetary dynamo, converting motion into magnetism. But this system is inherently unstable. At irregular intervals, sometimes after hundreds of thousands of years, sometimes after millions, the magnetic field weakens, distorts, and eventually reverses direction completely. During these periods of transition, the field does not vanish, but it becomes chaotic. Magnetic north may drift toward the equator, or even fragment into multiple poles. For a time, compasses would point in strange directions. The planet's protective shield against solar radiation could fluctuate wildly. To our distant ancestors, had they witnessed it, the sky itself might have appeared to shimmer with strange lights and storms of energy. The most recent full reversal, known as the Brun-Hess-Matuyama reversal, occurred roughly 780,000 years ago. Yet, evidence suggests that Earth may be due for another. The South Atlantic Anomaly, a region where the magnetic field is unusually weak, has been expanding rapidly, and satellites passing through it often experience malfunctions or data losses. Could this be an early sign that a reversal is already beginning? Mainstream geophysicists caution against panic. Magnetic reversals, they note, unfold over thousands of years, slow enough that life and civilization can adapt. Yet not all agree that the process is so benign. Some researchers have linked past reversals to mass extinctions, climate disruptions, or even spikes in cosmic radiation reaching the surface. The connection remains uncertain, but the timing, in several cases, is uncomfortably close. Then there are the more speculative theories. Some suggest that reversals could be triggered by external events, massive asteroid impacts, sudden changes in Earth's rotation, or gravitational alignments with the Moon or other planets. Others go further still, proposing that these magnetic flips might correspond to cycles of consciousness or even evolutionary leaps, as cosmic energy interacts with biological systems. None of these ideas have been proven, but they reveal how deeply the mystery stirs both scientific and philosophical imagination. After all, the magnetic field does more than guide compasses. It connects every living being to the very core of the Earth. When it shifts, could it subtly influence us as well? And what of human history? Some ancient cultures, it is said, recorded strange sky phenomena, brilliant auroras seen at low latitudes, compasses that failed, animals behaving erratically. Could these accounts hint at smaller magnetic disturbances in more recent times, brief localized echoes of the planet's deeper cycles? If so, we may be living not at the dawn of a catastrophe, but at the threshold of transformation. A world preparing once again to turn itself inside out. Itself, beneath the calm blue sky, beyond the reach of satellites and science, the core of the Earth continues to churn, slowly, inexorably. The same iron tides that have reversed the poles 1,000 times before still flow in darkness, shaping the magnetic veil that guards our planet. What will happen when that veil begins to twist again? Will humanity witness the next great reversal, or has it already begun quietly beneath our feet? From the deep, unseen movements within Earth's molten core, where magnetic forces shape the fate of the planet itself, our journey now drifts to a remote and silent wilderness, one that bears the scars of a cosmic encounter still not fully understood. Far in the heart of Siberia lies the Tunguska region, a vast, untamed expanse of taiga stretching endlessly beneath pale northern skies. Here, the air hangs heavy with isolation. The only sounds are the whisper of wind through larch trees and the distant cries of wild birds echoing across the marshes. Yet beneath this haunting calm lies the memory of one of the most powerful explosions ever witnessed on Earth, and a mystery that continues to challenge both scientists and nature itself. On the morning of June 30th, 1908, a blinding fireball streaked across the sky above the stony Tunguska River. Witnesses described it as a second sun, tearing through the atmosphere with a roar that shook the ground hundreds of miles away. Moments later, a massive shock wave flattened more than 2,000 square kilometers of forest, an area larger than many modern cities. Trees were scorched, splintered, and pressed flat against the ground in a radial pattern, their trunks pointing outward from a single invisible center. No crater was ever found. No meteorite fragments. No clear trace of what truly happened. What remains today are the trees, the silent witnesses of Tunguska's mystery. Many of them, flattened in that cataclysmic blast, have long decayed. But in their place, something remarkable occurred. Life returned, stronger, faster, and more resilient than anyone expected. In the decades that followed, scientists who ventured into the region noticed something extraordinary. The new trees growing in the blast zone, especially larches and pines, seemed to regenerate with unusual vigor. Their growth rings were broader than normal, indicating accelerated growth. Some reached maturity decades ahead of schedule, thriving in soil that should have been devastated. Why? Was it simply the result of open sunlight and nutrient-rich ash? Or did the Tunguska event somehow alter the biology of the forest itself? Mainstream explanations lean toward the natural. The explosion cleared vast areas of canopy, allowing sunlight to flood the ground. The fallen trees decayed quickly, releasing minerals back into the soil. With no competition and abundant light, the new generation of trees flourished, a straightforward, elegant cycle of destruction and renewal. And yet, anomalies persisted. Studies revealed that certain tree species near the epicenter displayed unusual genetic mutations. Growth rates fluctuated in ways not entirely consistent with environmental recovery alone. Some researchers detected subtle radiation effects, suggesting that the energy released at Tunguska may not have been purely mechanical. That possibility opened the door to deeper questions. If the blast was caused by a comet or meteor, as most scientists believe, why was there no evidence of impact material? No fragments, no crater, no residue consistent with known celestial bodies. Some have proposed that the object exploded mid-air, disintegrating before touching the ground. Others argue it may have been a comet nucleus composed primarily of ice, which vaporized completely upon entering the atmosphere. But there are other, more speculative possibilities, ideas that drift at the edge of accepted science. In the 1970s, Soviet physicists suggested the Tunguska event might have been caused by a natural gas explosion from within the Earth's crust, ignited by lightning or an atmospheric discharge. Others proposed a mini black hole passing through the planet, compressing air and releasing immense energy before exiting into space. A few even whispered of extraterrestrial origins, pointing to the symmetry of the blast pattern and the lingering electromagnetic disturbances detected afterward. Still, none of these theories fully explain the curious vitality of the forest that followed. Some botanists have compared Tunguska's regrowth to Chernobyl's Red Forest, a place where radiation initially killed, but where nature has since reclaimed the land with strange, accelerated adaptation. Could the Tunguska trees have been subtly influenced by the energy released that day, an energy not yet fully understood? Over a century later, satellite images reveal a circular scar still faintly visible across the Siberian landscape, a silent echo of that morning's blast. Yet within that circle, life thrives in defiance of reason, trees standing tall where once there was only devastation. It is as if the land itself remembers, but refuses to die. What secret lies buried beneath those roots? Was it the hand of nature reclaiming balance, or a trace of something beyond it? Something that touched the earth for an instant and vanished, leaving behind a quiet transformation? The trees do not answer. They simply grow, each ring marking another year since the sky fell over Tunguska, each one a reminder that even in the aftermath of unimaginable destruction, the earth finds ways to renew itself. But renewal does not always mean understanding. And in the endless Siberian silence, the mystery of Tunguska and its ever-thriving forest remains. From the scorched forests of Tunguska, where devastation gave way to inexplicable renewal, our path now leads into the silence of another landscape, one shaped not by flame, but by sand. A place where the earth itself seems to speak. Across the deserts of Central Asia, North Africa, and even the western United States, vast dunes rise like frozen waves. Under the weight of the sun, the air shimmers, the horizon bends, and the world feels suspended between dream and mirage. Yet, in some of these places, the silence is broken, not by wind nor by life, but by a deep, resonant hum. It is known as the phenomenon of the singing dunes, a natural sound so strange and haunting that it has been described for centuries as the voice of the desert itself. To stand among these dunes when they begin to sing is to feel the ground vibrate beneath your feet, to hear a low, sustained note rolling across the sand like the breath of an unseen instrument. The first written accounts stretch back to antiquity. In 13th century records, travelers along the Silk Road spoke of mountains that moan and valleys that chant. Marco Polo described the sands of the Gobi as producing the sounds of drums and bells, mysterious echoes that frightened caravans in the night. Bedouin nomads in Arabia told of dunes haunted by spirits, jinn trapped beneath the earth, their cries carried by the wind. But what could cause a desert to sing? Modern scientists have studied the phenomenon in places as far apart as Badain Jaran in China, Kongoran Els in Mongolia, the Namib Desert, and California's Death Valley. Despite the distance between them, these dunes share a peculiar ability. When sand avalanches down their steep slopes, set in motion by wind or by human footsteps, it triggers a deep, booming tone, often around 100 hertz, that can last for several minutes. The sound is not random. It resonates at a consistent pitch, sometimes harmonizing into chords. The dunes appear to function almost like musical instruments, their surfaces vibrating in unison. And yet, even now, no one can fully agree on how this natural orchestra works. The prevailing explanation points to friction between sand grains. Each grain, smooth and round, rubs against others as it slides downward. When the grains are of uniform size and perfectly dry, they begin to synchronize their motion, producing vibrations that amplify into sound. Essentially, the dune acts as a massive loudspeaker, one made not of metal or wood, but of countless grains of silica. But this neat explanation doesn't answer everything. Why do only a handful of dunes across the world produce this sound, when similar sands exist elsewhere? Why does the tone vary between locations, some producing deep thunder, others higher-pitched hums, when the sand appears nearly identical? And why in some years do the dunes fall silent altogether, as if something essential has been lost or muted within them? Some researchers suspect that microscopic films of moisture or subtle electrostatic charges between grains might alter the dune's acoustic behavior. Others point to hidden layers of sediment buried beneath the surface that may act as resonant chambers. Then come the more speculative ideas, those whispered beyond the bounds of pure science. A few observers have likened the phenomenon to Earth's geomagnetic resonance, suggesting that the dunes may somehow interact with electromagnetic fields or tectonic vibrations. Others have drawn comparisons to the Taos hum, or the Bristol hum, low-frequency sounds heard by select individuals in certain regions, as though the Earth were singing to itself in tones below human hearing. Some desert mystics, both ancient and modern, interpret the sound differently. To them, the singing dunes are living entities, their voices reminders of a time when the planet was more awake, more aware. In Mongolian folklore, the sounds are said to be the murmurs of hidden palaces beneath the sand, where spirits of the wind dwell eternally. Yet, for all our instruments and theories, one truth remains. No recording, no experiment, can fully capture the strange emotion of hearing a dune sing in person. The sound doesn't just travel through the air, it moves through the body, resonating deep in the chest, as though the listener has momentarily become part of the desert itself. To experience it is to sense the vastness of time, to feel the patience of the land. And as the vibrations fade into silence, a question lingers in the heat. Is this simply the physics of sand and motion, an elegant accident of nature? Or is the desert revealing something more ancient, more conscious, an echo of the Earth's own hidden song, heard only by those who listen long enough to understand it? From the shifting dunes that whisper their strange, melodic songs across the world's deserts, our journey now moves into one of the most remote and forbidding landscapes on Earth, a place where silence reigns absolute, and the land itself seems to have been scorched by something unearthly. Here, deep within the Libyan desert, sunlight gleams across the sand in flashes of gold and pale green. Scattered across hundreds of square kilometers are pieces of glass, smooth, translucent, and impossibly pure. Some lie half-buried, others glint on the surface like forgotten jewels of the sun. These are the fragments of a mystery that has puzzled geologists, historians, and astronomers alike. Libyan desert glass. At first glance, the pieces appear almost ordinary, irregular lumps and sheets, many no larger than a hand. But when held to the light, they glow with a luminous intensity unlike anything found elsewhere in nature. Chemical analyses reveal that this glass is among the purest silica ever discovered on Earth, up to 98% pure, a level of refinement that even modern industry struggles to achieve. And yet, these fragments are ancient, roughly 28 million years old by current estimates. The question is, what could have created them? For decades, scientists have studied the vast stretch of desert known as the Great Sand Sea, near the border of modern-day Egypt and Libya, where these glassy relics are found. There are no volcanic deposits nearby, no sign of lava flow, and no large crater to mark the impact of a meteorite. Yet something extraordinary must have occurred, something that heated the surface of the desert to over 1,600 degrees Celsius, hot enough to melt sand into glass. Early explorers proposed that the glass might have formed during ancient lightning storms. A bolt of lightning can indeed fuse sand into small glassy tubes known as fulgurites. But the sheer scale of the Libyan desert glass field makes this explanation implausible. Lightning could never generate such vast quantities of material, nor sustain such even temperatures across so wide an area. Others turned to the skies. Could a meteorite or comet have exploded above the desert, releasing a heat pulse powerful enough to melt the sand without leaving a crater? The idea is not without precedent. In 1908, over Tunguska in Siberia, a similar aerial explosion flattened thousands of square kilometers of forest. The Libyan desert glass might be the ancient echo of such an event. A celestial detonation so intense that it turned desert sands into glass in an instant. In 2019, scientists analyzing tiny minerals trapped within the glass discovered something startling: zircon crystals that had transformed into badalayite, a mineral that forms only under extreme pressure and heat, conditions typically found in meteorite impacts. This evidence strengthened the theory of a cosmic origin, suggesting that the glass was born from an explosion in the atmosphere, possibly caused by a comet fragment entering Earth's skies millions of years ago. But even this explanation leaves questions unresolved. If a comet or meteor did cause it, where is the crater? Why is the glass distributed so evenly, rather than in the chaotic pattern typical of impact debris? Some researchers now suspect the event may have been unlike anything we've ever witnessed: a plasma fireball or a shockwave generated high above the surface, capable of vaporizing sand but leaving no trace of impact below. And then there are theories that step further beyond conventional science. Some ancient astronaut enthusiasts have pointed to the glass's astonishing purity and even distribution as evidence of something artificial, perhaps the remnants of a long-lost technology, or even a forgotten catastrophe from humanity's deep prehistory. They note that pieces of Libyan desert glass were prized in ancient Egypt. Most famously, a scarab carved from the material was discovered in the pectoral of Tutankhamun himself, its radiant yellow-green stone gleaming at the heart of the young pharaoh's jewelry. To those who favor symbolic connections, this link between glass and royalty, between desert fire and divine transformation, is no coincidence. Could the ancients have known, or at least sensed, that the material came from the heavens? Of course, to modern science, such claims remain speculation, but still, the mystery persists. Even with advanced tools, even with satellites mapping every square kilometer of the desert, the precise cause of Libyan desert glass continues to elude complete explanation. Was it lightning magnified by rare atmospheric conditions? A comet's fiery death high above the sands? Or something stranger, an event whose nature and energy lie beyond our current understanding of the Earth and its sky? In the searing quiet of the Great Sand Sea, the fragments remain, unchanged for millions of years, their surfaces smooth, their colors glowing softly beneath the desert sun. They are silent witnesses to an ancient, unimaginable heat, and to a moment when the earth itself was touched by fire from the heavens. Even now, as the winds shift the dunes and time erases all trace of what came before, the question endures: what kind of power once turned sand into stone and left behind beauty born of destruction? Beneath the tranquil surface of the world's oceans, in the silent blue void where sunlight dissolves into shadow, exists a creature that quietly challenges one of nature's most immutable laws: mortality itself. It is known as Turritopsis dohrnii, the so-called immortal jellyfish. Drifting almost invisibly through warm, temperate waters, this tiny organism, no larger than a fingernail, possesses a biological ability that seems to defy reason: the power to revert its own life cycle, again and again, escaping death in a loop of perpetual renewal. From a distance, it appears ordinary, its translucent bell pulsing gently, tentacles trailing like fine threads of glass. Yet beneath its fragile form lies one of biology's deepest enigmas. When threatened by starvation, injury, or age, the jellyfish does something no other complex animal is known to achieve. It transforms itself back into a polyp, returning to its earliest stage of life. From there, it grows anew, a rebirth that may repeat indefinitely. To some, it is the closest thing to biological immortality ever discovered. Scientists first documented this remarkable ability in the 1990s off the coast of the Mediterranean. Researchers observed that, unlike typical jellyfish, which die soon after reproduction, Turritopsis dohrnii could reverse its own cellular development, a process termed transdifferentiation. Cells that had specialized for certain functions could transform into entirely different types, repairing or recreating tissues from scratch. In human terms, it would be as though a grown adult reverted into an infant, retaining all memories yet shedding every trace of age or damage. The discovery sparked waves of fascination and disbelief. Could this humble jellyfish hold the secret to eternal life? Was this a quirk of evolution or a hint of something far deeper, something nature rarely allows us to see? In laboratories around the world, biologists began to probe its molecular code, searching for clues within its DNA. They found a complex web of proteins and genetic switches that regulate stress, regeneration, and cellular aging. Some of these mechanisms resemble those found in humans, particularly in stem cells, the very cells that heal and regenerate tissue. But despite decades of study, no one has fully unraveled how Turritopsis triggers its miraculous transformation. It is as though the blueprint for immortality is written in a language science can glimpse but not yet read. And so, questions began to spread beyond the realm of biology. If nature has engineered one creature capable of escaping death, could there be others? Could this process exist in dormant forms within other species, or even, in some distant evolutionary memory, within ourselves? Some researchers whisper about hidden potential buried deep in the genetic code of all life, an ancient mechanism suppressed by evolution, perhaps for reasons we do not understand. Others, more philosophical, see in this jellyfish a mirror of the universe's cyclical nature. Stars are born, burn, collapse, and rise again as new stars. Forests die, decay, and renew through the soil they leave behind. Could Turritopsis dohrnii be another expression of this cosmic rhythm, a small, pulsating echo of an endless pattern that binds life and death together? Yet even within its mystery lies a paradox. Though it may never truly die of old age, the immortal jellyfish is far from invincible. It can still fall prey to predators, disease, or environmental changes. Its immortality is not a triumph over death, but an evasion, a delicate dance around it. In the deep sea, where countless threats linger unseen, its gift may simply extend a fragile existence rather than guarantee eternity. Still, its very presence forces us to rethink the boundaries of biology. It suggests that death, as final as it seems, might not be an absolute law but a biological habit, one that nature has, at least once, chosen to break. What could humanity learn from such a creature? Could understanding its secret one day allow us to slow our own aging, or regenerate organs, or reverse disease? Or is its immortality a reminder that life's greatest mysteries are not meant to be conquered, only observed with awe? As the camera drifts through the dim light of the ocean, the jellyfish glows faintly, pulsing like a living ember in the deep. In this quiet alien world, time itself seems to hesitate, and one cannot help but wonder if such a being exists, quietly defying the cycle of life and death. What else might be hidden in the uncharted depths, rewriting the rules of existence while we gaze unknowingly from above? From the silent blue vastness of the open ocean, where the horizon vanishes and light fades into shifting gradients of indigo, an ancient traveler moves beneath the waves. Massive and deliberate, its presence is both graceful and immense. The whale, one of Earth's largest living beings, follows a path that stretches thousands of miles across open sea. Yet astonishingly, it does so without landmarks, maps, or visible guides. From the frozen reaches of the Antarctic to the balmy waters near the equator, it moves with certainty, as though reading from an invisible chart written upon the planet itself. How do whales navigate such impossible distances with such uncanny precision? How does a creature, deep beneath the surface and often in darkness, find its way across a vast and featureless ocean? These are questions that have lingered for generations, questions that continue to puzzle scientists even today. The phenomenon first drew attention when researchers began tagging and tracking whales in the late 20th century. What they found was extraordinary. Gray whales migrating more than 10,000 miles round trip, humpbacks traveling from Alaska to Hawaii with near-perfect accuracy, blue whales moving seasonally across hemispheres, often returning to the very same feeding grounds year after year. Even when storms alter the seas, or when magnetic disturbances ripple across the Earth, whales seem to know precisely where they are going. Some scientists suggest that whales, like migratory birds and sea turtles, may possess a kind of internal compass, a biological sense finely tuned to the planet's magnetic field. Tiny crystals of magnetite found in the tissues of several marine species could allow them to detect subtle shifts in geomagnetic lines, translating invisible energy into directional awareness. If true, it would mean that whales navigate not by sight or sound, but by feeling the Earth itself, a kind of sensory perception beyond human understanding. And yet, this theory alone cannot explain everything. In recent years, recorded strandings, events in which entire pods of whales beach themselves inexplicably, have added layers of complexity to the mystery. Some of these strandings coincide with sudden geomagnetic anomalies, suggesting that disorientations in the Earth's magnetic field may interfere with their guidance system. But in many cases, no such disturbances occur. Whales appear healthy, the waters calm, and yet they turn toward the shore, as though compelled by something unseen. Could their navigation be influenced by more than magnetism? Others have proposed that whales might also use celestial cues, following the position of the sun, or even the faint light of the stars visible through the surface layers of the sea. There is evidence that some species possess remarkable sensitivity to polarized light, allowing them to read the subtle angles of sunlight even underwater. Then there is sound, the most pervasive force in the ocean. Whales are masters of acoustics, communicating through haunting songs that can travel across entire ocean basins. Some researchers speculate that these creatures may use low-frequency sounds not only for communication, but also for navigation, listening to the unique acoustic fingerprint of each region, the way sound echoes off seafloor ridges and continental shelves. Each ocean, after all, has its own deep voice. Could whales be listening to the planet itself, following an auditory map that only they can hear? Still, there are those who venture further into the unknown. A few fringe theorists suggest that whale navigation may involve forms of perception humanity has barely begun to explore: electrical sensitivity, quantum-level magnetoreception, or even a kind of collective memory passed through generations, encoded not in behavior but in biology. Could it be that whales are tapping into something ancient and universal, a planetary rhythm that once guided all life long before humans ever learned to sail? And yet, for all our technology, for all our satellites and sonar, we remain only spectators. The whales continue their migrations, following paths they have known for millions of years, paths traced through oceans that have changed countless times, yet somehow remain familiar to them. They carry with them a knowledge both immense and silent, a wisdom written not in words, but an instinct. Perhaps what draws us to this mystery is not simply curiosity, but recognition. For in watching whales navigate the vast unknown, we glimpse something of ourselves, the search for direction, the longing to find our way home across the endless seas of existence. And so, the question remains, when a whale sets its course across the deep, what is it truly following? The pull of magnetism? The sound of the earth? Or something older, something written in the quiet pulse of the world itself, guiding them through the darkness of the sea and the mysteries of time? From the quiet stillness of an ordinary room, the impossible sometimes leaves its mark. A chair reduced to ash, a patch of scorched flooring, and at the center, what remains of a human body, burned far beyond recognition. Curtains nearby hang untouched. Newspapers sit undisturbed. The fire seems to have chosen its victim with eerie precision. This is the unsettling phenomenon known as spontaneous human combustion, a mystery that has haunted scientists, doctors, and skeptics for centuries. The first widely recorded accounts date back to the 17th century, when reports began surfacing in Europe describing people found burned to death with no apparent source of ignition. Their surroundings, curiously, often showed little to no damage. One of the most famous cases occurred in 1951 in St. Petersburg, Florida. The victim, Mary Reeser, was discovered in her apartment, her body almost entirely consumed by fire, leaving only a leg and part of her skull. The rest of the room remained virtually untouched, except for a small circle of heat damage beneath her remains. Fire investigators, baffled by what they found, noted that such intense burning should have required temperatures over 3,000 degrees Fahrenheit, far beyond what any domestic fire could produce. Yet there was no evidence of accelerants, no electrical faults, and no signs of foul play. This strange pattern appeared again and again. Across continents and decades, from England to India, from Italy to the United States, victims of alleged spontaneous combustion were often found in similar conditions: partially incinerated bodies, confined burn zones, and an absence of external causes. Could the human body truly ignite from within? Scientists have long struggled to explain these unsettling events. Some have proposed that alcohol consumption might make the body more flammable, a theory popular in the 18th century when many victims were found to be heavy drinkers. Yet, modern chemistry quickly dispelled the idea. Even with high blood alcohol levels, the body simply does not burn in this way. Others suggested that static electricity, lightning, or ball lightning might have played a role, rare, unpredictable forces of nature capable of producing localized bursts of heat. But these explanations often fall short of matching the forensic evidence. One of the more grounded scientific hypotheses involves what researchers call the wick effect. In this scenario, an external ignition source, such as a cigarette or a spark, sets fire to clothing, which in turn melts body fat and allows it to act like candle wax, sustaining a slow, smoldering burn. The body, wrapped in its own fuel, burns gradually, sometimes for hours, leaving only bones and ashes behind. The wick effect has been demonstrated in controlled experiments, lending credibility to its role in certain cases. And yet, it still does not explain everything. In some incidents, no external fire source is ever found. In others, the rapidity and completeness of the combustion far exceed what the wick effect could achieve. Then there are the reports that challenge the boundaries of physics itself. Eyewitnesses describing faint blue flames, or victims said to have emitted smoke moments before bursting into fire. These accounts, though rare, have kept the mystery alive. Could something inside the human body, perhaps chemical, electrical, or even biological, trigger such an event? Some fringe theorists have speculated that spontaneous combustion could be linked to unstable chemical reactions involving gases or lipids within the body. Others have suggested that sudden surges of bioelectric energy, perhaps influenced by stress or emotional intensity, might act as a spark from within. A few even reach beyond science, proposing metaphysical explanations, energetic imbalances, curses, or forces beyond the material realm. Though such ideas sit far from mainstream research, they reflect humanity's enduring attempt to understand what reason alone cannot easily explain. Forensic science has advanced enormously in recent decades, yet spontaneous human combustion continues to resist full understanding. Every now and then, another case emerges, enigmatic enough to reopen the question: how does flesh ignite without flame? How does destruction occur without chaos? Perhaps the truth lies somewhere between chemistry and mystery, between the explainable and the inexplicable, waiting for science to bridge the gap. Or perhaps it reminds us that, even in an age of reason, there are still moments when the ordinary can collapse into the unthinkable. Somewhere, in a quiet room, a lamp still glows beside an untouched chair. The air is calm, the floor unburned. And yet, the question lingers. What unseen forces might dwell within the human body, capable of turning life itself into fire? From the icy silence of Antarctica, a continent of endless white and ancient cold, something strange breaks the monotony of the landscape. Amid the towering cliffs of the Taylor Glacier, a crimson flow spills out across the frozen face of the ice, staining it with a haunting shade of deep red. It looks like blood, thick, dark, and startling against the purity of its surroundings. Known as blood falls, this bizarre cascade emerges from one of the most remote and inhospitable places on Earth. It seeps slowly from a fissure in the glacier, streaming downward like a wound in the ice itself. For over a century, this natural anomaly has puzzled explorers, geologists, and biologists alike. How could something so vividly alive appear in a land where almost nothing can survive? The story begins in 1911, when Australian geologist Griffith Taylor first stumbled upon the site during one of the earliest expeditions to Antarctica's McMurdo Dry valleys. What he saw seemed almost impossible: a waterfall of red liquid flowing from the heart of a glacier that should have been frozen solid. At the time, scientists assumed the coloration came from microscopic algae, perhaps trapped within the ice. It was a convenient explanation, one that aligned with familiar patterns of life and biology. But when samples were later examined, no trace of algae was found. The mystery deepened. Decades later, as analytical techniques advanced, researchers discovered that the water emerging from beneath the glacier was unlike any other found in Antarctica. It was ancient, sealed off for millions of years in a subglacial pocket far below the surface. The red hue, it turned out, was not organic, but chemical, caused by high concentrations of iron. When the iron-rich brine met the oxygen of the open air, it oxidized, just as blood darkens when exposed to air. That finding solved one question, but raised many others. How could liquid water exist beneath a glacier in a place where temperatures rarely rise above freezing? And what process had kept it sealed and flowing for so long without solidifying into ice? Scientists discovered that the water was hypersaline, so saturated with salt that it could remain liquid even in sub-zero conditions. Yet this was no ordinary salt water. It was an isolated brine, a self-contained ecosystem buried under layers of ice, untouched since a time long before human civilization. In its depths, life found a way to persist, if not thrive. In 2018, a team of researchers confirmed the presence of microbial life within this alien environment. These microorganisms survive without sunlight, feeding on iron and sulfur compounds in complete darkness. They exist in an ecosystem that has been sealed off from the rest of the world for millions of years, like a time capsule from an ancient Earth. But even with these discoveries, questions remain. How did these microbes evolve to survive in such extreme isolation? What chemical or biological processes sustain them after so long? And more curiously, could this strange subglacial world offer clues about life elsewhere in the universe? Some scientists now look to blood falls as a natural analog for environments beyond our planet. The subglacial lake system beneath Taylor Glacier resembles in some ways the icy oceans thought to exist beneath the crusts of Jupiter's moon Europa or Saturn's moon Enceladus. If life can survive in such conditions here on Earth, cut off from light, warmth, and fresh air, then perhaps it can also exist in those frozen alien seas. Yet beyond the excitement of discovery, there is something almost unsettling about blood falls. The idea that a hidden world of organisms, completely independent of the surface, has continued its ancient cycle beneath our feet evokes a sense of awe and unease. What else might lie beneath Antarctica's vast ice sheets, sealed away from time itself? Some fringe theories propose that the phenomenon could be part of a much larger network of subterranean lakes and tunnels stretching beneath the continent. A few even speculate that remnants of ancient civilizations, or unknown life forms, might be trapped within these hidden systems. While no evidence supports such claims, the sheer mystery and isolation of the region invite speculation. In a place where few have ever stood, and where even the air feels untouched by time, almost anything seems possible. The landscape around Blood Falls remains one of the driest, coldest, and most alien on Earth, a paradox of fire and ice, where the color of life seeps from the heart of eternal frost. It challenges our understanding of where life can exist and how it endures. As the crimson water continues its slow, silent flow, one can't help but wonder, what secrets still lie locked beneath Antarctica's frozen crust? Could there be other hidden pockets of ancient ecosystems waiting to be revealed? Or is Blood Falls a singular reminder that even in the most lifeless corners of our planet, the pulse of something ancient still beats unseen beneath the ice? From the farthest reaches of the cosmos to the depths beneath Antarctic ice, humanity has always searched for the unknown. Yet, one of the greatest mysteries of all doesn't lie out there, beyond the stars. It lies within us. Hidden inside every human cell, woven into the spiraling structure of our DNA, is something scientists call the Dark Genome. It is a place not of empty space, but of silence, of information that refuses to speak in any language we fully understand. When the Human Genome Project was completed in 2003, it was heralded as one of science's crowning achievements. For the first time in history, we had mapped the complete sequence of human DNA, over 3 billion base pairs of genetic code. Researchers expected that this map would explain almost everything about what makes us human, how our bodies form, how diseases arise, even how consciousness might emerge from biology. But when the results came in, something unexpected appeared. Of the entire human genome, only about 2% actually contained instructions for making proteins, the building blocks of life. The rest, roughly 98%, seemed to do nothing. At first, scientists dismissed it as junk DNA, a collection of evolutionary leftovers, genetic debris from ancient viruses, or fragments of genes that once served a purpose but had long since gone dormant. It was convenient to believe that the mystery was simply noise in an otherwise elegant system. Yet over time, that explanation began to crumble. As genetic research deepened, patterns emerged within the so-called junk. Certain sequences appeared to switch genes on and off. Others seemed to influence when and where specific traits were expressed. Some were active only in specific tissues or at particular stages of development, like hidden levers controlling the body's most delicate operations. The more scientists looked, the less it resembled junk, and the more it seemed like an intricate network of unseen regulators, a vast shadow system running parallel to the genetic code we thought we understood. Could this be the hidden architecture of life? Today, what was once dismissed as meaningless is known by a new name, the Dark Genome. It encompasses the mysterious regions of DNA that remain uncharted, whose roles are still unclear. Some estimate that as much as half of our genome is composed of transposable elements, genetic jumping genes capable of copying and moving themselves around. Others point to long, non-coding RNAs that may help orchestrate complex cellular functions, subtly guiding evolution itself. But even with modern tools like CRISPR and high-throughput sequencing, the dark genome resists clarity. Every discovery seems to raise more questions than it answers. Why do some of these sequences appear almost identical across vastly different species, as if preserving a universal message written in the language of life? And could the code's silent regions hold the key to understanding what makes human consciousness, or even intelligence, possible? Some researchers have begun to wonder whether the dark genome might contain instructions beyond physical biology, mechanisms that affect behavior, perception, or the very way organisms interact with their environment. Others, more speculative still, ask whether this genetic silence could hide traces of something older. Could it carry imprints from a time before humanity itself, information passed not just through evolution, but through unknown origins? A few fringe thinkers have even dared to suggest that the dark genome may not be random at all, but intentional, a kind of biological encryption. If that were true, who or what might have written it? Nature itself? Or something far beyond our current comprehension? For now, mainstream science treads carefully. The mystery remains grounded in biology, in the slow unraveling of molecular complexity. But the implications ripple outward. If so much of our DNA is still unreadable, then how much of who we are, our instincts, emotions, and potential, remains hidden in that silent code? What if the secrets to diseases we cannot cure, or to abilities we have yet to understand, are buried not in the genes we can read, but in the ones we cannot? It is humbling to realize that, after decades of progress, the human genome remains as enigmatic as ever. The more we decode it, the more it resembles a cosmic riddle, a vast biological manuscript filled with gaps, omissions, and faint whispers from evolution's earliest experiments. Perhaps deep within those uncharted sequences lies a record of life's true origin. Or perhaps it is something far stranger, a message written not for us, but through us, a silent conversation between life and the universe itself. For now, the dark genome keeps its secrets. And as science continues to listen, to map, to probe, to translate, it is left with one haunting question. Are we merely deciphering our biology, or uncovering something that has been waiting quietly to be found? From the vast and silent stretches of the Indian Ocean, a red island emerges, a land unlike any other on Earth. Madagascar. It is a place where evolution has taken its own secret path, where strange creatures and ancient trees whisper in voices that science is still trying to interpret. Here, life seems to follow forgotten rules, as if time itself had chosen to move differently. But among its dense forests and arid plains, there is one mystery that defies explanation, a phenomenon both beautiful and unsettling. The locals call them zombie fire trees. At first glance, they appear ordinary, gnarled trunks rising from the dry, cracked soil, their bark pale and ghostly, like bleached bone under the equatorial sun. Many are baobabs, ancient sentinels that have watched centuries of storms, droughts, and human passage. Yet what makes these trees remarkable is what happens after they die. Even when they've withered, hollowed, or burned from within, some of them refuse to fall. Their roots remain alive, pulsing faintly beneath the earth. And in the stillness of night, witnesses claim to see them glow. Soft, ember-like light flickers from the cracks in their bark, orange and red, as if fire were trapped inside, breathing. Sometimes the light travels along the trunk in delicate veins, like blood returning to a long-dead body. Other times, the entire tree appears to shimmer faintly, as though lit from its core. Locals speak of them in hushed tones. To many Malagasy villagers, the phenomenon is not just strange, it is sacred. They believe these trees are guardians, housing ancestral spirits who refuse to depart. When the forest burns, the spirits do not die. They linger, glowing with what remains of their life force. To Western science, however, the story begins elsewhere. Madagascar's soils are rich in phosphates and minerals, and its decaying vegetation often supports colonies of bioluminescent fungi, organisms capable of producing light through chemical reactions involving luciferin and luciferase. Under the right conditions of heat and humidity, these fungi can spread through the wood of fallen or dying trees, causing them to emit an eerie, natural glow. It's a phenomenon known elsewhere as foxfire, recorded in forests from North America to Southeast Asia. But the zombie fire trees behave differently. They glow for far longer periods, and in some cases, appear to ignite spontaneously, even when no biological or chemical reaction should be possible. In the early 1990s, a small group of French researchers studying Madagascar's dry, deciduous forests near Manabe tried to document the effect. Night vision cameras captured faint pulses of light moving within certain baobab trees, light that persisted even when samples of the wood were taken to controlled environments. Without the humidity, without the fungi, the wood still glowed. No clear cause was identified. Some hypothesized trapped methane or phosphorus gas igniting spontaneously when exposed to oxygen. Others suggested piezoelectric effects caused by pressure changes within the wood, though such effects are rarely seen in organic materials. Then there were the older stories, the ones that science rarely discusses. Ancient Malagasy oral traditions tell of trees that remember fire, trees said to have been struck by lightning centuries ago and never fully extinguished. These trees, it was said, carried the fire of the sky within them, burning slowly through the ages. A few environmental historians have even drawn parallels to reports from early Portuguese sailors who described seeing flaming trees along Madagascar's coasts during the 16th century. Could these have been the same phenomena observed today, or something entirely different? There is another theory, whispered in the margins of scientific forums, that the tree's apparent life after death may be linked to the unique microbial ecosystem within their roots. Some microbiologists believe symbiotic bacteria could generate small electric currents, bioelectrical energy, strong enough to produce light under certain conditions. But if that's true, then these trees are more than plants. They are natural circuits, living batteries, sustained by unseen forces deep within the soil. Still, none of these explanations are complete. The zombie fire trees remain a riddle, a convergence of biology, geology, and myth. And perhaps that is what makes them so haunting. A tree that dies, yet glows. A forest where fire breathes without burning. It reminds us that even in an age of science and satellites, there are still places on this earth where the line between life and death is blurred, where nature writes its own quiet miracles in languages we have yet to learn. Somewhere tonight, on a windswept plain in Madagascar, a dead tree flickers against the dark. Is it the last breath of life, or the echo of something that refuses to die? From the quiet avenues of Havana, where pastel facades fade under the Caribbean sun and the sea hums beyond the Malecon, a mystery once rippled through the humid air. one that defied logic, unsettled governments, and left scientists grasping for explanations. It began without warning. In late 2016, American and Canadian diplomats stationed in Cuba reported strange sensations, sudden bursts of pressure, disorienting sounds like metal grinding against glass, or the high-pitched whine of invisible machinery. Some felt waves of heat pass through their skulls. Others described dizziness, nausea, or a powerful sense of confusion, as though the world around them had momentarily shifted out of alignment. Then came the physical effects: hearing loss, memory lapses, persistent headaches. Some victims could no longer concentrate for more than a few minutes at a time. For many, recovery took months. For others, the symptoms lingered indefinitely. Doctors were baffled. There were no obvious environmental toxins, no infectious diseases, no evidence of radiation. And yet the scans told a darker story. A number of patients exhibited signs of brain trauma, mild but unmistakable, similar to what one might expect from a concussion. But these people had not been struck. There had been no accident, no visible injury. Soon, a name emerged: Havana Syndrome. At first, it seemed confined to Cuba's capital. But over the following years, similar cases appeared in China, Germany, Austria, and even near Washington, D.C. The same strange sounds, the same debilitating symptoms, the same sense of being struck by something unseen. What could cause such a thing? The first theories were grounded in reason. Perhaps it was mass psychogenic illness, a psychological reaction spreading through a highly stressed diplomatic community. After all, the Cold War tensions that once haunted Havana had never entirely vanished. Could anxiety alone produce symptoms so real, so measurable? But that explanation soon faltered. Medical imaging showed structural changes in the victims' brains, tiny differences in white matter, balance centers, and auditory processing regions. These were not imagined. Something physical had happened. Attention turned to technology. Some scientists proposed that microwave radiation might be the culprit, a focused beam of energy that could cause internal heating in brain tissue without leaving burns on the skin. It was a chilling idea, but not a new one. During the mid-20th century, the Soviet Union was known to experiment with microwave-based surveillance and potential non-lethal weaponry. In the 1950s, U.S. embassy workers in Moscow were reportedly exposed to low-level microwave radiation for years, an incident that sparked decades of research into the biological effects of directed energy. Could Havana Syndrome be a modern echo of those experiments? In 2020, a U.S. National Academy's report supported the plausibility of directed pulsed radio frequency energy as a possible cause. The theory gained traction, yet even as it did, it raised more questions than answers. Who would have the technology to produce such an effect? And why target diplomats? Some investigators suggested a secret surveillance or data harvesting experiment gone wrong. Others whispered of deliberate testing, a new class of weapon designed to incapacitate without detection. A few even speculated that the phenomenon might not be human-made at all, that atmospheric or geomagnetic anomalies could create localized bursts of pressure or resonance. But the evidence remained elusive. No device was ever found. No pattern of electromagnetic interference could be consistently detected. Even victims within the same building sometimes experienced different symptoms, or none at all. Then came the counter-theories. A group of acoustics experts identified the sound recordings made by one victim and traced them, remarkably, to the mating calls of crickets common in the region. The noises that seemed mechanical or technological were in fact biological. But could the sounds alone explain the brain injuries? Few believed so. Others argued for environmental toxins, pesticides, mold, or chemical agents used in building maintenance. Some pointed to inner ear disorders or undiagnosed viral infections. Yet none of these explanations fully accounted for the suddenness, precision, or geographic spread of the events. And so the debate continues. The debate, years later, after countless investigations, committees, and classified reports, the mystery of Havana Syndrome remains unresolved. Governments have acknowledged the reality of the victim's suffering, but not the source. Each new study seems to clarify one piece, only to cloud another. Was this a weapon of the future, or a trick of perception amplified by fear? A coordinated attack, or an environmental coincidence wrapped in political tension? In Havana, the sea still breaks quietly against the wall, indifferent to human confusion. The embassies stand as they always have, white, sun-bleached, and silent. Yet for those who lived through those moments of invisible assault, something changed forever. Perhaps the answer lies not in technology or politics, but in something we've yet to understand about the human brain, its fragility, its resilience, and its deep, mysterious connection to the unseen forces around it. Because if the mind can be harmed without touch, influenced without sound, or reshaped without cause, what else might be possible? From the dense, emerald rainforests of South America, where humidity clings to every leaf and life itself hums in 1,000 unseen rhythms, lurks a creature so small, so deceptively fragile, that few would suspect it of harboring one of nature's most lethal secrets. Among the tangled roots and shadows of the Amazon, hidden beneath curling leaves and resting along bark the color of decay, moves a silent killer, the Lonomia caterpillar. It looks harmless, soft, fuzzy, almost beautiful in its camouflage. But beneath those delicate spines lies a venom unlike anything else known to science, a cocktail so complex, so deadly, that even the smallest touch can unravel the human body from within. For centuries, these caterpillars went unnoticed. Local people regarded them with a kind of quiet caution, aware that brushing against certain tree trunks could result in strange fevers, bleeding gums, or sudden death. But the outside world took little notice, until tragedy forced them to. In the 1980s, in the humid southern forests of Brazil, reports began to surface of sudden, inexplicable hemorrhages. Healthy individuals, farmers, loggers, children, were dying from uncontrollable internal bleeding after nothing more than a casual touch against a tree. When doctors investigated, they found a pattern. Every victim had come into contact with the same unassuming creature, the Lonomia obliqua caterpillar. What scientists discovered in its venom would baffle even the most experienced toxicologists. Unlike snake venom, which kills by paralyzing or destroying tissue, the Lonomia's venom disrupts the body's ability to clot blood. Victims bleed internally, their organs overwhelmed as the natural balance between coagulation and dissolution collapses. But that was only the beginning. The venom didn't just thin blood, it rewired it. The enzymes within seemed to trick the body into dissolving its own clots, creating a chain reaction so rapid and uncontrollable that even minor wounds became catastrophic. The question arose, how could such a delicate creature evolve such a powerful biochemical weapon? Researchers began to study its venom in detail, isolating over a dozen unique proteins, each interacting with the human body in ways that defied conventional understanding. Some of these compounds were unlike anything found in other animals or plants. The caterpillar, it seemed, had evolved its venom not for defense or attack, but for something far more subtle, perhaps protection from microbial infection, or even as a means of self-regulation in the complex ecosystems of the forest. Still, the mystery deepened. Unlike most venomous species, which inject their toxins through fangs or stingers, the Lonomia's venom is delivered through hollow, hair-like spines that break into the skin with the lightest brush. Victims often don't even feel the sting until hours later, when symptoms begin to appear: dizziness, nausea, dark bruising beneath the skin. Then comes the bleeding, sometimes from the nose, the gums, even the eyes. In severe cases, the body's internal organs begin to fail, not from poison in the usual sense, but from a total biochemical collapse. In one of the earliest documented mass incidents, a group of farmers in southern Brazil encountered a cluster of Lonomia caterpillars hidden along a tree trunk. Within days, several of them were hospitalized with severe hemorrhaging. A few did not survive. Their deaths prompted urgent research, and what scientists found shocked them further. The venom's proteins didn't merely cause bleeding. They interacted with human enzymes in a way that could, in theory, be reversed. This paradoxical property made the Lonomia both one of the most dangerous and most fascinating species on Earth. Out of its deadly chemistry emerged a potential cure, not just for its own venom, but for certain types of strokes and blood clots. Today, laboratories continue to study the caterpillar's toxins, hoping to unlock their secrets. Yet, even as science makes progress, the creature's mystery endures. Why does it possess such a potent, sophisticated venom? Evolution rarely produces complexity without reason. Did environmental pressures, predators, parasites, microbial threats somehow push this humble caterpillar to develop a defense system rivaling that of the deadliest snakes? Or could there be an undiscovered ecological role for its venom, one that we have yet to perceive? And perhaps the most unsettling question of all, what else lies undiscovered within the millions of insect species that still inhabit the rainforests, each carrying chemistries we barely understand? When night falls in the jungle, the Lonomia disappears into the darkness once more, motionless, blending perfectly with the bark. Yet its presence lingers. In the caution of those who know its danger, and in the fascination of scientists who see within this creature's deadly secret a key to understanding life itself. A creature so small it could rest on a fingertip, yet capable of bringing down a full-grown human. A life form whose venom kills and heals in equal measure. And so the mystery remains. In the heart of the rainforest, amid the endless pulse of life and decay, one caterpillar continues to defy explanation. What forces shaped such a weapon, and what might it reveal about nature's most hidden designs? From the sun-baked plains of ancient North America to the humid forests of early Europe, the fossil record tells a story of predators, of tooth and claw, of survival and extinction. But hidden deep within that geological timeline lies a strange, silent chapter. A period when one of Earth's most iconic hunters simply vanished. It is known as the Cat Gap, a baffling 20 million year absence in the evolutionary history of felines. Between roughly 25 and 18 million years ago, the fossil record of true cats, those elegant carnivores that would one day stalk the world's continents, simply disappears. Before and after this period, cats dominate their ecosystems. But within this mysterious window of time, they are nowhere to be found. Instead, their ecological roles seem to have been filled by other predators, dog-like creatures, bear dogs, and strange, extinct carnivores that have long since faded into prehistory. Why did the cats vanish? And how did they later return, as if nothing had happened? The story begins during the Oligocene epoch, around 25 million years ago. The Earth was changing. Vast grasslands were spreading, climates were cooling, and prey species were evolving to become faster and more agile. This was an age of adaptation and extinction. Many early carnivores struggled to keep pace with the shifting environment. Among them were the nimravids, sometimes called false saber-toothed cats. These cat-like predators had evolved long before modern felines, equipped with saber-like fangs and muscular frames. But despite their resemblance, they were not true cats. Around the time the Cat Gap begins, these formidable creatures vanish completely from the fossil record. And then, silence. For millions of years, no trace of any feline ancestor appears anywhere on Earth. Paleontologists have searched deserts, cliffs, and fossil beds across the globe, trying to piece together what happened. Was it climate change, competition, disease, or something far stranger, an evolutionary reset that science has yet to explain? One prevailing theory suggests that cats may have simply lost the evolutionary race, outcompeted by early canids, the ancestors of modern dogs. During this period, dog-like species diversified rapidly, spreading across continents and filling the ecological niches that cats once held. Fossil evidence shows that these predators thrived in open plains, while felines, adapted for ambush and stealth, may have struggled to survive in the newly formed grasslands. But others argue the gap might not represent true extinction at all, merely a blind spot in the fossil record. Perhaps early cats existed during that time but lived in regions where fossilization was rare or conditions for preservation were poor. If so, their absence might be more illusion than fact, a reminder that the geological record is as fragile and incomplete as the bones it preserves. Still, some scientists find this explanation unsatisfying. The sheer length of the gap, millions of years, suggests that something more profound occurred. Could a shift in Earth's magnetic fields, a sudden climate oscillation, or even a mass extinction event now lost to time, have erased an entire lineage of predators? The mystery deepens when we look at what happened after the gap. Roughly 18 million years ago, true cats, members of the Felidae family, suddenly reappear, fully formed and astonishingly well adapted. Fossils from this time show creatures unmistakably feline in structure: retractable claws, specialized teeth for slicing flesh, and the stealthy build that defines the modern cat. It's as though evolution pressed pause, then resume. How could such a lineage vanish for so long, only to return with no clear ancestor connecting the dots? Some paleontologists have proposed that the earliest true cats may have evolved elsewhere, perhaps in regions not yet explored, or in habitats where fossilization left no trace. Others suggest they evolved from an unknown branch of carnivores, distinct from the nimravids and other cat-like creatures that came before them. And then, of course, there are more speculative ideas. Some fringe researchers point to unexplained evolutionary patterns that seem to defy simple environmental reasoning. Was there a sudden mutation event, something triggered by cosmic radiation, or an atmospheric change that wiped out one species while giving rise to another? Could the cat gap mark not extinction but transformation, a silent evolutionary leap? Mainstream science, cautious and evidence-driven, avoids such leaps of logic. Yet, even the most conservative explanations cannot fully close the gap. To this day, there is no fossil sequence that clearly bridges the vanished nimravids with the earliest true cats. It remains one of the strangest and most persistent absences in the story of life on Earth. In the end, what we call the cat gap may be more than a missing chapter. It may be a mirror, reflecting how much of our planet's history still lies buried, waiting to be uncovered. So, what truly happened during those lost millions of years? Did the cats perish, unseen, in some forgotten extinction? Or did they simply retreat into the margins of evolution, watching, waiting, before reclaiming their throne? The stones are silent. The fossils end. And somewhere between the known and the unknowable, the cats of prehistory remain missing. Shadows in time, erased from the record, yet not from the imagination. From the vastness of prehistory to the silent intelligence of the natural world, our journey now leads us somewhere quieter, somewhere rooted in green life rather than stone or bone. Imagine a field at dawn, dew glistening on blades of grass, leaves trembling as if in faint awareness of the light's return. Beneath the surface, unseen, networks of roots stretch outward, touching, sensing, reacting. In this tranquil setting lies a question that has quietly unsettled science. Can plants remember, and even pass those memories to their offspring? The idea seems almost poetic, something out of ancient myth or animist tradition. For millennia, humans have spoken to trees, blessed harvests, and believed that forests possess memory. But modern research has begun to suggest that such beliefs might hold more truth than once imagined. Across laboratories and greenhouses around the world, biologists are finding hints that plants do more than simply respond to their environment. They may retain traces of experience, storing information that influences the generations that follow. The phenomenon is called transgenerational memory, a concept that blurs the line between biology and something that feels almost conscious. At its simplest, it refers to the ability of a living organism to pass on acquired responses, behaviors, tolerances, or stress adaptations to its descendants. In animals, we call this epigenetic inheritance. But in plants, the mechanisms appear even more intricate and far more mysterious. One of the earliest clues emerged from experiments on Arabidopsis thaliana, a small flowering plant often used in genetic research. Scientists exposed several generations of these plants to drought conditions, carefully tracking how they responded over time. Astonishingly, the offspring of stressed plants seemed better equipped to survive future droughts, even when they themselves had never experienced a lack of water. Something within them had remembered. The same pattern appeared in other species. Plants exposed to cold, heat, toxins, or pests appeared to learn from the experience, then quietly embedded that knowledge into the molecular architecture of their seeds. These weren't changes in DNA sequence, but in how genes were expressed. Tiny chemical marks called methyl groups that acted like bookmarks, preserving lessons from the past. But here is where the mystery deepens. Unlike animals, plants have no brain, no central nervous system, no neurons or synapses in which memory might reside. So how does this learning occur? Some researchers suggest that it's a purely chemical process, an elegant form of biochemical recording, where stress triggers gene expression patterns that persist for generations. Others suspect something more complex, involving networks of electrical signaling and even subtle electromagnetic communication between cells. The implications stretch far beyond botany. If plants truly store and transmit memory, could entire forests carry records of centuries past? Could the trees that stand today remember the droughts, fires, and storms of their ancestors, and quietly prepare their offspring to endure them again? Consider, for instance, the ancient olive groves that still thrive across the Mediterranean, or the baobab trees of Madagascar, some of which are thousands of years old. These species have endured eras of climatic upheaval, pestilence, and human interference. Yet they persist, often flourishing in conditions that should have erased them long ago. Is their resilience purely genetic? Or could it be a living echo of memory? Skeptics caution that much of what is called memory in plants might simply be adaptive biology, a survival mechanism honed by natural selection rather than conscious recollection. Yet others argue that the persistence of molecular changes across generations defies such simplicity. After all, if memory requires only the stable transmission of information, does it really matter whether neurons are involved? Some fringe theorists go further, speculating that plants might possess a distributed intelligence, a kind of networked awareness spanning root systems, fungi, and microbial symbionts. They point to studies showing that trees communicate through underground fungal networks, sending nutrients or distress signals to one another. Could such networks also share adaptive memories, linking generations and species in ways we are only beginning to understand? In the quiet rhythm of nature, such possibilities are easy to overlook. A tree does not move or speak, and yet its entire existence is an act of remembering, the slow accumulation of seasons, droughts, and sunlight etched into rings of wood. What, then, defines memory? Must it belong only to the mind, or can it live within matter, encoded in the chemistry of life itself? As scientists continue to probe the genetic whispers passed from one plant generation to the next, the question remains open, suspended in the stillness of the natural world. Perhaps every seed carries not just the promise of growth, but the memory of survival. And perhaps, somewhere in the vast intelligence of the Earth's ecosystems, the plants are remembering still, silently, patiently, and with a wisdom that predates us all. Far beyond our solar system, in the quiet vastness of the Cygnus constellation, lies a star that refuses to behave like any other. Unremarkable at first glance, a faint ordinary point of light among millions, it drew astronomers' attention not for its brilliance, but for its strange, inexplicable behavior. Its brightness did not remain steady. Instead, it fluctuated in ways that confounded even the most sophisticated models of stellar dynamics. This star, now known as Tabby's star, or KYC 8462852, has become one of the most perplexing mysteries in modern astronomy. The story begins in 2009, when the Kepler Space Telescope, designed to detect exoplanets by monitoring tiny dips in starlight, recorded an anomaly. Stars, as a rule, dim and brighten according to predictable patterns: pulsations, eclipses by orbiting planets, or the slow changes of aging. But Tabby's star defied all expectations. Its light sometimes dipped by as much as 20%, an amount far greater than any known planet could obscure, and the pattern was irregular, with no apparent rhythm or explanation. Astronomers initially suspected the usual culprits: dust clouds, comet swarms, or a debris disk surrounding the star. After all, stars are rarely solitary, and circumstellar material is common. But as more data was gathered, these explanations began to falter. The dips in brightness were too erratic, the light curves too complex to fit neatly into any standard model. The star's behavior became more than a curiosity. It became a puzzle that resisted solution. The name Tabby's star emerged from the work of Tabitha Boyajian, an astronomer who meticulously analyzed the Kepler data and drew attention to the star's unusual dimming. As the anomaly gained publicity, hypotheses multiplied. Some suggested swarms of comets or massive asteroid collisions as possible causes. Others pointed to intrinsic stellar variability, theorizing that some unknown internal process might cause the star to flare unpredictably. Yet none of these explanations fully captured the scope of the mystery. The dips were irregular, some lasting just days, others weeks, and their magnitudes varied wildly. Moreover, historical photographic plates dating back over a century hinted that the star might have gradually dimmed by as much as 14% over the past 100 years. Could a star itself change so significantly on such a human timescale? Then came the fringe theories, the ones that captured public imagination and inspired heated debate among astronomers. Among the most provocative, the possibility of alien megastructures. The idea proposed that enormous artificial constructions, perhaps orbiting solar collectors or other stellar engineering projects, might partially obscure the star. While highly speculative, the notion highlighted just how enigmatic Tabby's star truly is. Even the most advanced astrophysics could not offer a conclusive answer. Scientific caution prevailed, of course, Surveys in infrared, radio, and optical wavelengths sought evidence of heat or radiation that such megastructures would emit. None was found. The star did not behave like a Dyson sphere, if one existed. And yet, the irregularity of the dimming persisted, resisting conventional explanations. Other theories have explored the possibility of interstellar dust clouds drifting between Earth and the star, or unusual arrangements of planetary debris shaped by gravitational forces we do not yet fully understand. Some suggest that perhaps a combination of multiple mechanisms, a swarm of comets, dust, and stellar variability, creates the illusion of inexplicable behavior. Even the star's own magnetic activity has been considered, though nothing observed matches the scale of the dimming. Despite decades of observations, Tabby's star remains an enigma. It challenges assumptions about stellar behavior, about the predictability of celestial mechanics, and about our understanding of what is normal in the cosmos. Each new measurement adds detail, but no explanation reconciles all aspects of its light fluctuations. In a sense, the star is a reminder of the universe's vastness and its capacity to confound. It is a cosmic riddle, patiently holding its secrets in plain sight, visible to anyone who looks up, yet refusing to reveal its inner workings. For scientists, it is a case study in humility. Even with the most sophisticated instruments, some phenomena elude comprehension. For dreamers and theorists, it is a symbol of wonder, a star that might be ordinary, might be extraordinary, and might, for now, remain forever unknowable. As we watch Tabby's star flicker across the void, questions arise that touch both science and imagination. What hidden processes shape the lives of stars? How much of the cosmos remains obscured by our limited perspective? Could there be mechanisms, natural or otherwise, that we have yet to conceive? The star twinkles, sometimes bright, sometimes dim, across the centuries and light years that separate it from us. And in its silent, erratic pulse, it reminds us of one enduring truth. The universe is vast, complex, and often stranger than our theories. For now, Tabby's star continues its quiet, irregular dance, a cosmic enigma inviting us to wonder, to study, and to acknowledge the mysteries that still await discovery in the night sky. Beyond the shimmering stars of our night sky, beyond the familiar constellations and the swirling arms of the Milky Way, lies a force so immense it silently commands the motion of entire galaxies. It is invisible, yet its presence is undeniable, felt through the inexorable pull it exerts across hundreds of millions of light years. This is the Great Attractor, a cosmic mystery that has left astronomers both awed and perplexed for decades. The story begins not with observation, but with motion. In the late 20th century, astronomers mapping the velocities of galaxies noticed a puzzling phenomenon. Entire clusters of galaxies, including our own local group, were drifting toward a single region of space at staggering speeds, hundreds of kilometers per second. The source of this attraction, however, remained obscured behind veils of cosmic dust and gas that block our view of the heart of the universe. It is as though a colossal gravitational hand tugs at the very fabric of the cosmos, yet its form remains hidden from sight. The Great Attractor is located in a part of the sky known as the Zone of Avoidance, a region obscured by the dense plane of the Milky Way. Telescopes trained on this area face a thicket of stars, interstellar dust, and gas clouds that prevent a clear optical view. Even so, the pull is unmistakable, inferred from the motions of galaxies far beyond the obstruction. The farther scientists look, the more the evidence accumulates. This is no minor anomaly, but a gravitational well of extraordinary scale, whose influence shapes the structure of the universe on a massive, almost incomprehensible level. What exactly is creating this pull? Mainstream explanations suggest a combination of massive clusters of galaxies and unseen dark matter, a mysterious substance that neither emits nor absorbs light, yet constitutes roughly 85% of the universe's total mass. These galactic concentrations, along with vast clouds of dark matter, could account for much of the gravitational tug. Yet, the details remain elusive. When astronomers peer through X-ray and infrared surveys, they find dense regions, but nothing that fully explains the sheer magnitude of the attraction. It is as if the cosmos itself is hiding a secret, a massive structure that resists direct observation. Over the years, various names have been proposed for the entities that might constitute the Great Attractor. The Norma Cluster, a dense concentration of galaxies, lies near the gravitational center, but it alone cannot account for the phenomenon. Some studies point toward even larger structures, superclusters, filaments of dark matter, and voids stretching across hundreds of millions of light-years, as contributing to the gravitational imbalance. Each discovery adds pieces to the puzzle, yet no single explanation fully satisfies the evidence. The Great Attractor's mystery deepens when one considers its implications for our understanding of the universe. Gravity, after all, is a force we can measure, model, and predict. And yet, here is a region where predictions falter, where known structures fail to account for observed motion. Could there be something entirely unknown? An undiscovered supercluster? An immense filament of dark matter? Or some form of exotic matter that interacts with gravity in ways we do not yet comprehend? The very term Great Attractor reflects both awe and humility, acknowledging that the universe may harbor secrets far beyond our current understanding. Speculative theories have emerged, some bordering on the extraordinary. Could the Great Attractor represent a relic of a primordial structure, a leftover from the universe's earliest moments, whose influence has persisted through cosmic time? Might it hint at interactions with dimensions beyond our perception, or gravitational anomalies that challenge Einstein's general relativity? While these ideas remain largely hypothetical, they illustrate the profound sense of wonder inspired by the phenomenon, a reminder that the universe often defies expectation. For astronomers, the challenge is both technical and philosophical. Observational tools must pierce the dense foreground of our galaxy to glimpse what lies beyond, using infrared surveys, X-ray telescopes, and radio waves to trace mass where light cannot reach. Each new survey reveals structures previously hidden, yet the full picture remains incomplete, tantalizingly out of reach. It is a cosmic shadow, present in its effects, absent in direct detection. And yet, perhaps the true enigma of the Great Attractor is not merely its mass or location, but what it represents. A reminder that the universe is far more interconnected and dynamic than our senses can perceive. The motions of galaxies, the flow of cosmic structures, even the path of our own Milky Way, all are influenced by forces we barely glimpse, whispering of vast networks of matter and energy stretching across space. As we chart the heavens and trace the pull of this invisible titan, one question lingers. What lies at the heart of the Great Attractor, and what secrets of the cosmos does it conceal? Its presence is undeniable, its influence immense, yet its true nature remains hidden. In the quiet expanses between galaxies, the Great Attractor continues to tug, patiently shaping the universe, leaving us to wonder what might still be waiting in the darkness. Far beyond the familiar constellations, in the silent depths of intergalactic space, a signal flashes and vanishes in the blink of an eye. A brief, almost imperceptible burst of energy that travels across billions of light-years to reach our telescopes. These phenomena, known as fast radio bursts, or FRBS, are among the most enigmatic signals ever detected in the cosmos. Mysterious flashes that arrive without warning, leave no trace of origin, and defy our understanding of astrophysics. The first FRB was discovered in 2007, hidden in archival data collected by the Parkes Radio Telescope in Australia. At first, astronomers assumed it was a fluke, some interference, a technical glitch, or terrestrial noise masquerading as a cosmic event. But as more bursts were recorded, patterns began to emerge, and it became clear. These signals were real. They were incredibly bright, yet astonishingly brief, lasting mere milliseconds, and each carried more energy than the sun emits in an entire day. What could produce such a sudden and powerful outburst? Theories abound, and each brings with it a sense of wonder and mystery. Among the mainstream explanations, magnetars, neutron stars with extraordinarily powerful magnetic fields, are often considered prime candidates. A magnetar flare could release immense energy in a fraction of a second, producing the brief, intense radio pulses we observe. Pulsars, the spinning remnants of massive stars, and the collision of compact objects like neutron stars or black holes, have also been proposed as potential sources. Yet despite these plausible models, no single explanation accounts for all observed FRBS. Some bursts repeat, often with unpredictable intervals, while others appear only once, vanishing without trace. The signals arrive from all directions of the sky, originating from galaxies billions of light years away, far beyond the Milky Way. The repeating bursts, in particular, challenge conventional astrophysics, suggesting a mechanism capable of surviving repeated outbursts over extended periods. Adding to the intrigue, some FRBS have been traced with remarkable precision to specific host galaxies, revealing environments both ordinary and extraordinary. Star-forming regions, remote dwarf galaxies, and locales rich in magnetic activity. Each discovery raises new questions. Why are some galaxies hosts to multiple FRB sources, while others appear silent? What hidden structures or processes in these galaxies could trigger such ephemeral yet powerful phenomena? Fringe theories have also entered the conversation, some reaching into realms as speculative as they are imaginative. Could these bursts be signals from advanced extraterrestrial civilizations, communications sent across the cosmos with technologies beyond our comprehension? While there is no direct evidence to support such notions, the sheer unpredictability and energy scale of FRBS makes such speculation irresistible to the human imagination. Even if unlikely, the possibility hints at the vast unknowns that still lie in the universe's depths. FRBS also challenge our perception of time and distance. Traveling billions of light years, each burst is a snapshot of the distant past, a fleeting echo from a universe long gone. They are cosmic postcards, arriving at random, and yet carrying within them the signatures of their origin, clues embedded in dispersion measures, polarization, and frequency shifts. By decoding these faint imprints, astronomers hope to unravel not only the nature of the bursts themselves, but the properties of the vast space through which they traveled, probing intergalactic plasma and the large-scale structure of the cosmos. Despite intensive observation, each new detection deepens the mystery. Thousands of fast radio bursts have been catalogued, yet a unifying theory remains elusive. Some astronomers suggest we may be witnessing multiple astrophysical phenomena, distinct in origin yet producing superficially similar signals. Others posit that entirely new physics, unaccounted for in current models, may be required to fully understand the bursts. The universe, it seems, has a way of delivering its messages in whispers, brief, fleeting, and profoundly mysterious. FRBs are a reminder that even in the era of powerful telescopes and advanced simulations, the cosmos can still surprise us, revealing phenomena that challenge our assumptions and ignite our curiosity. Each burst, lasting mere milliseconds, carries a story billions of years old, traveling across the vast cosmic ocean to reach us, and then gone, leaving only questions in its wake. As we continue to listen to the sky, scanning for the next sudden flash, one question lingers. What cosmic engines, hidden in the depths of distant galaxies, produce these ephemeral bursts of energy? And what secrets of the universe, its structure, its origins, or even its unknown possibilities, might still be encoded in these brief, fleeting signals from the deep? The search continues, a patient endeavor across space and time, as fast radio bursts illuminate the boundaries of our knowledge, beckoning us to look farther, listen more closely, and wonder what mysteries still await in the darkness beyond. In the still, quiet nights of August 15, 1977, a radio telescope at Ohio State University's Big Ear Observatory captured a signal unlike any other. For 72 seconds, the universe seemed to speak directly to Earth, sending a transmission so unusual, so distinct from the cosmic background, that it left its observer in awe. The astronomer who recorded it, Jerry R. Eman, circled the sequence on the printout and wrote in the margin a single word: "Wow." And thus, the WOW signal entered the annals of unexplained phenomena. The signal itself was striking. A strong, narrow-band spike in the 1420 megahertz range, precisely the frequency at which hydrogen, the most abundant element in the universe, naturally emits radio waves. This detail alone sparked fascination, because such a frequency is considered a potential channel for interstellar communication. The WOW signal was extraordinary in its intensity, short-lived and localized to a small patch of sky near the constellation Sagittarius, a region far beyond our solar system. Yet, after decades of observation, it has never been detected again. What could produce such a sudden, isolated signal? Natural sources in space, pulsars, quasars, or solar flares, emit radio waves, but their signatures are generally periodic, sustained, or spread across a broader range of frequencies. The WOW signal, by contrast, was sharp, clean, and fleeting. It rose above the background noise with a clarity that suggested, at least momentarily, the possibility of something deliberate. Was it a message, a cosmic anomaly, or merely a quirk of instrumentation? Mainstream explanations have often leaned toward terrestrial interference, a satellite, a fleeting reflection, or an Earth-based source masquerading as a distant transmission. Yet the Big Ear Observatory was carefully shielded from known interference, and the characteristics of the signal, its duration, frequency, and Doppler shift, align poorly with human-made sources. Astronomers have scoured the archives, compared telescope positions, and ruled out many conventional possibilities, but none fully accounts for the singularity of the observation. Over time, theories expanded to include natural astrophysical phenomena. Could a comet or an asteroid, passing through the telescope's field, emit a brief radio signal? Might an unusual combination of hydrogen clouds and cosmic events create a one-time spike? In 2017, a study suggested that two comets in the same region of space could have produced the emission, yet the debate remains far from settled. Each proposed explanation fits part of the data, but none captures the entire puzzle. The exact intensity, the sudden onset, and the vanishing that left astronomers staring at empty skies. For decades, the WOW signal has ignited the imagination of scientists and the public alike. Its timing and frequency raise profound questions about life beyond our planet. Could it have been a transmission from an extraterrestrial civilization, briefly crossing the void to reach us? The suggestion is tantalizing, yet caution is essential. Science demands evidence, and the signal's one-time appearance denies us the opportunity for verification. Unlike pulsars or repeating cosmic phenomena, the WOW signal exists in memory and print, but not in reproducible data. Even as technology has advanced, with radio telescopes capable of sweeping vast portions of the sky and detecting faint signals from galaxies billions of light-years away, no replica of the WOW signal has emerged. Its elusiveness deepens the mystery. Perhaps it is a cosmic whisper we were fortunate enough to catch once, a fleeting imprint of events or entities beyond our comprehension. Perhaps it is a natural event so rare and subtle that it occurs once in millennia. Or perhaps it is a message deliberately aimed at a future observer, intended for a brief moment of discovery. What makes the WOW signal particularly haunting is its combination of clarity and impermanence. In 72 seconds, the universe hinted at something extraordinary, and then it returned to silence. Each subsequent search has become a dialogue with the unknown, a careful listening for the faintest echo of that singular moment. It challenges astronomers to think beyond conventional sources, to imagine possibilities constrained neither by terrestrial expectations nor by the limits of our current understanding. As we continue to scan the heavens, tuning our instruments to the silent songs of the cosmos, the WOW signal reminds us of the universe's capacity to surprise. It is a testament to patience, curiosity, and wonder, a brief yet indelible encounter that continues to provoke questions. What created it? Was it a natural event, a fleeting anomaly, or something far more profound? For now, the signal remains unresolved, lingering as a reminder that, in the vast expanse of space, mysteries await that are both tangible and elusive, whispering of secrets we may only glimpse once, and perhaps never fully understand. In October 2017, astronomers made a discovery that sent a ripple of astonishment through the scientific community. A slender, elongated object moving through our solar system on a trajectory unlike any comet or asteroid observed before. It was swiftly named Oumuamua, a Hawaiian term meaning scout or messenger, a fitting moniker for the first known interstellar visitor detected passing through our celestial neighborhood. Its presence was fleeting, yet the data it left behind would challenge our understanding of space, motion, and the very nature of objects beyond our solar system. Oumuamua's path was remarkable from the outset. Unlike typical comets, which trace predictable elliptical orbits around the Sun, this object arrived on a hyperbolic trajectory, clearly originating from beyond the confines of our solar system. Its speed and angle of approach suggested it had traveled for millions, perhaps billions of years, wandering between the stars before finally being captured briefly by the Sun's gravitational influence. Yet, its behavior defied expectations in another, more perplexing way. It was accelerating as it left the solar system. Careful analysis revealed a subtle yet measurable deviation from the path predicted by gravitational forces alone. Objects in space follow the pull of gravity, yet Oumuamua appeared to be propelled slightly faster than gravity could account for. For scientists, this anomaly posed a puzzle. What force could be pushing it outward against the Sun's gravitational embrace without leaving a detectable trail of gas or dust as comets normally do? Mainstream explanations suggest that the acceleration could result from outgassing, jets of gas expelled from its surface as solar heat warmed volatile ices. Comets display this phenomenon frequently, leaving visible tails of vapor. But Oumuamua exhibited no such cometary tail, no detectable coma, and no spectroscopic evidence of gas or dust. Its reddish metallic-hued surface, reminiscent of asteroids, seemed inconsistent with a volatile-rich comet. The usual models fell short, leaving a gap between observation and theory that has intrigued and frustrated astronomers alike. The shape and rotation of Oumuamua added further layers of mystery. Photometric measurements indicated an extremely elongated or flattened form, perhaps 10 times longer than it was wide, tumbling unpredictably through space. Such an unusual shape is unseen among known solar system objects, raising questions about its origin. Was it a fragment from a destroyed planet or star system? Could it be a piece of material ejected during the violent formation of another star system, traveling for eons before chance brought it near Earth? Speculative theories have also emerged, some daring to suggest that Oumuamua could be artificial, a probe or a light sail from an extraterrestrial civilization, using radiation pressure to glide through interstellar space. While this idea remains highly controversial and far from mainstream acceptance, the very consideration underscores the profound strangeness of the object. A celestial wanderer that resists conventional classification, leaving scientists to contemplate possibilities both natural and extraordinary. Despite rapid observational efforts, Oumuamua's visit was brief. Within weeks, it had passed the closest point to the Sun and was already retreating toward the dark stretches of interstellar space. Telescopes could capture only fragments of data, and the object soon became too faint to observe. What remained is a record of motion, brightness, and spectrum, a fleeting fingerprint of a traveler from beyond our solar system. The acceleration itself continues to be a focal point of investigation. Could there be a mechanism as yet undiscovered in physics, or a combination of effects so subtle that our instruments barely detected them? Might there be interstellar objects whose behavior does not conform neatly to solar system analogs, hinting at a diversity of phenomena in the galaxy we have barely begun to explore? Each question points to the vast unknown that Oumuamua represents, a reminder that even a small object, passing silently and briefly through our solar system, can challenge our assumptions and expand our sense of cosmic possibility. As Oumuamua fades into the depths of space, it leaves behind more than a trail of data. It leaves a sense of wonder and the realization that our cosmic neighborhood is far from isolated. Objects from distant star systems can wander into our view, ephemeral messengers of processes, forces, and histories that span billions of years. Its brief visit invites reflection on the scale, complexity, and mystery of the universe, and poses a question that lingers in the minds of astronomers and dreamers alike. What other interstellar travelers, with behaviors beyond our expectations, might one day pass through our solar system, and what secrets might they carry from the stars? As humanity cast its mechanical explorers into the far reaches of the solar system, venturing beyond the planets and into the vast darkness beyond, something curious began to emerge in the data. The Pioneer 10 and Pioneer 11 spacecraft, launched in the early 1970s to chart the outer planets, were meant to send back precise measurements of their trajectories as they sailed into deep space. Yet, decades after their launch, scientists noticed an anomaly, subtle, persistent, and inexplicable, a small, unaccounted-for acceleration tugging at the spacecraft as they traveled toward the edge of the solar system. This peculiar force, directed roughly toward the Sun, became known as the Pioneer Anomaly. It was tiny, on the order of 10 billionths of a meter per second squared, yet it persisted over millions of kilometers of travel. In the careful calculations of navigational experts, it refused to disappear. Every measurement, every telemetry reading confirmed that something was acting on the spacecraft, something that could not be explained by the gravitational pull of the Sun, the planets, or known forces within our solar system. The anomaly was first quantified in the late 1980s, when data from Pioneer 10, the first probe to pass Jupiter, and Pioneer 11, which journeyed past Saturn, revealed a systematic deviation from expected trajectories. The spacecraft were slowing down ever so slightly more than calculations predicted. For a phenomenon so slight, the implications were immense. Could this hint at new physics, a modification of gravity over vast distances, or some unknown interstellar force influencing objects as they drifted farther from the Sun? Mainstream explanations initially explored the mundane. Tiny forces that might result from onboard thermal radiation, minute leaks of propellant, or the recoil effect of heat escaping from the spacecraft's radioactive power sources. Each possibility was painstakingly modeled. Engineers and physicists examined every potential source of asymmetry, every reflection of heat off the spacecraft's body, every small jet of gas that might impart momentum. Slowly, these effects accounted for a significant portion of the anomaly, but even with sophisticated modeling, a small discrepancy remained, tantalizing in its persistence. The Pioneer Anomaly also invited speculation that reached beyond conventional science. Could the mysterious acceleration hint at phenomena like dark matter subtly influencing objects within the solar system? Or might it suggest that our understanding of gravity itself was incomplete, a force behaving differently at the vast distances between planets and the edge of interstellar space? While these ideas remain speculative, they underscore the anomaly's significance. Even the smallest deviation in a spacecraft's path can ripple into profound questions about the universe's fundamental laws. The spacecraft themselves, aging and distant, became silent witnesses to this mystery. Pioneer 10, the first human-made object to traverse the asteroid belt and pass Jupiter, continues to drift ever farther from the Sun, more than 12 billion kilometers away, its radio signal fading into the void. Pioneer 11, which explored Saturn before heading toward the constellation of Aquila, follows a similarly lonely trajectory. Both carry the story of a subtle, enigmatic pull, a gentle whisper of forces not fully understood. Researchers continue to study archival data, reanalyzing decades-old telemetry with modern computational techniques, hoping to extract insights missed in earlier analyses. The Pioneer Anomaly stands as a reminder of the limits of precision and the surprises that can emerge even in the most carefully monitored missions. It reveals how, in the vast reaches of space, tiny effects, almost imperceptible, can persist, defying initial expectations and inspiring deeper inquiry. Perhaps the most haunting aspect of the Pioneer Anomaly is its persistence across time and distance. Here, in the silent void beyond Neptune, the spacecraft drift, guided by forces we only partially comprehend. They are mechanical envoys, bearing witness not only to the planets they once studied, but also to the mysteries that lie hidden in the subtle mathematics of motion, in the faintest tugs that escape our immediate understanding. As we continue to track distant probes, sending robotic observers into the outer solar system and beyond, the Pioneer Anomaly invites reflection. What other unseen forces might be at play in the cosmos, subtly guiding objects through space in ways we have yet to fully perceive? Could there be principles or phenomena lying at the threshold of detection, quietly shaping trajectories across billions of kilometers? The spacecraft carry our questions into the void, a testament to human curiosity and the enduring mystery of the universe, waiting for future explorers to untangle the subtle threads that connect the known to the unknown. Floating above the dense, swirling clouds of Venus, one of our closest planetary neighbors, lies an atmosphere cloaked in mystery and contradiction. The planet's thick shroud of sulfuric acid and carbon dioxide has long painted Venus as a world inhospitable to life. A relentless furnace, its surface hot enough to melt lead, its pressures crushing enough to flatten a spacecraft. Yet, in 2020, a subtle signal from high in Venus's upper clouds challenged everything we thought we knew about the planet. Traces of phosphine, a gas often associated on Earth with biological processes. Detected through radio observations using the James Clerk Maxwell Telescope in Hawaii, and later confirmed by the Atacama Large Millimeter/Submillimeter Array in Chile, the presence of phosphine sent a ripple of astonishment through the scientific community. On Earth, this molecule is produced predominantly by anaerobic microorganisms, living in environments devoid of oxygen, and its sudden detection in the acidic, sunlit clouds of Venus prompted questions that reach far beyond planetary chemistry. Could life, or some unfamiliar chemical process, exist above the planet's inhospitable surface, suspended in the high-altitude clouds, bathed in sunlight yet shielded from the crushing pressures below? the discovery itself was methodical, rooted in careful spectroscopy. Scientists observed absorption lines at millimeter wavelengths, identifying phosphine with a specificity that left little room for doubt. The challenge, however, lies in understanding how it could persist in an environment so extreme. Venus's clouds are not merely acidic, they are turbulent, roiling with winds that exceed hundreds of kilometers per hour. Ultraviolet radiation from the sun relentlessly bombards these clouds, breaking down complex molecules. On a planet where nothing seems stable, how could phosphine endure? Mainstream scientific explanations have explored a variety of non-biological processes. Volcanic activity, lightning, or chemical reactions involving minerals lofted from the surface have all been proposed. Yet Venus is geologically enigmatic. While its surface bears evidence of volcanism, the extent and activity of these volcanoes remain uncertain, and no known chemical pathway easily produces phosphine in the quantities observed. Even high-energy phenomena, such as the planet's ultraviolet light-driven photochemistry, failed to fully account for the gas's persistence. Each conventional explanation encounters obstacles, leaving a gap that continues to intrigue and confound. The implications of this discovery are profound, and they extend into the realm of speculation. Could there exist microbial life, adapted to the acidic droplets that drift in Venus's upper atmosphere, metabolizing in ways we cannot yet imagine? Might there be unknown chemical reactions occurring in the clouds, driven by energy sources or mineral interactions we have yet to detect? Or, in a more radical sense, could phosphine be a signal of entirely novel processes, hinting at physics or chemistry alien to Earth's experience? Venus has always fascinated observers, from its bright appearance in the night sky to its twin-like comparison with Earth. Yet, the planet remains a study in extremes. Its surface heat exceeding 460 degrees Celsius, atmospheric pressures nearly 90 times those at sea level, and winds in the upper clouds circling the planet in just 4 Earth days. To imagine life, or even sustained chemical reactions producing phosphine, existing in such conditions challenges the boundaries of known science. And yet, the detection forces us to consider that habitability is not confined to the temperate, oxygen-rich environments we are accustomed to studying. Observational limitations compound the mystery. Remote sensing from Earth can only capture fleeting glimpses of Venus's complex atmosphere, and the dense cloud layers obscure the planet's surface and lower atmosphere. Future missions, such as atmospheric probes or orbiters designed to sample the clouds directly, may offer clarity. But for now, we are left with the tantalizing data and the questions it evokes. The molecules exist, their signature unmistakable, yet their origin remains uncertain, suspended in a planetary environment that defies easy explanation. The phosphine signal also serves as a humbling reminder of the gaps in our understanding of the cosmos. Venus, so close and familiar, may harbor processes entirely alien to Earth, whether biological, chemical, or as yet undiscovered. It challenges scientists to consider new models, to rethink assumptions about where and how life, or complex chemical systems, might exist. And it invites us, the observers, to imagine worlds where the extraordinary can emerge in the most hostile environments. As researchers continue to analyze data, refine models, and plan ambitious missions to probe Venus more directly, the mystery of phosphine endures. It hangs in the planet's upper atmosphere like a question waiting to be answered, a whisper of possibility, hinting that even in the most forbidding clouds, there may be phenomena yet unseen. What secrets does Venus still guard? And could those secrets include evidence of life in a place we once assumed was utterly barren? The answers remain hidden in the thick yellow clouds, awaiting the careful gaze of future explorers to illuminate what might still lie above the blazing surface of our enigmatic sister planet. Far beyond the warmth of the sun, where sunlight weakens to a pale glow and temperatures plummet to near absolute zero, Neptune drifts in silent majesty. Its deep azure atmosphere, perpetually stirred by supersonic winds and mysterious currents, paints a world both alien and mesmerizing. Among the most intriguing features captured by the Voyager, 2 spacecraft during its 1989 flyby were the dark spots, immense storm-like vortices, some larger than Earth itself, swirling across the planet's cloud tops with hypnotic motion. Yet, in the decades since their discovery, a peculiar and unsettling phenomenon has emerged. These colossal storms often vanish, leaving scientists to ponder their fleeting existence and the forces that govern them. The first of these, the Great Dark Spot, appeared in Neptune's southern hemisphere as a giant, elongated vortex with winds surpassing 2,100 kilometers per hour. It was a storm of unimaginable scale, its shadowy presence a stark contrast against the planet's vivid blues and whites. However, when the Hubble Space Telescope revisited Neptune a few years later, the spot had disappeared entirely, replaced by a calm expanse or sometimes by a smaller, less distinct vortex. What could cause such enormous features to vanish so abruptly in a planetary atmosphere? Unlike Jupiter's more enduring Great Red Spot, Neptune's dark storms seem ephemeral, as if the planet's dynamics are constantly erasing and rewriting its atmospheric story. Scientists have sought to understand these disappearing giants through atmospheric modeling and observation. Mainstream explanations often point to Neptune's extreme weather system. The planet's internal heat, combined with rapid rotation and high-speed winds, generates turbulence that can tear vortices apart or dissipate them over time. Some models suggest that these storms are manifestations of upwelling and sinking gas, creating temporary pressure systems that are inherently unstable. The transient nature of dark spots might be an intrinsic feature of Neptune's exotic meteorology, where nothing remains constant for long. Yet, even with sophisticated simulations, mysteries linger. The sheer scale and speed of these storms challenge existing models of fluid dynamics. How can such massive vortices form so quickly, yet disappear seemingly without a trace? Could there be unknown interactions between Neptune's upper cloud layers and deeper atmospheric currents, or even between the atmosphere and the planet's magnetic field, influencing the formation and destruction of these storms? The persistence and sudden vanishing of dark spots remain difficult to reconcile with the relatively slow, predictable evolution of similar phenomena on other planets. Occasionally, new spots appear in unexpected locations, suggesting that Neptune's atmosphere is in a constant state of flux, as if the planet's own rotation and internal heat engines are painting and erasing features across its vast canvas. Some researchers have speculated that these storms might even hint at more complex or exotic processes, involving chemical or thermal instabilities that are not yet fully understood. Could unseen forces deep within Neptune's mantle or core be subtly shaping the behavior of its clouds, creating patterns that emerge and vanish without warning? While such ideas remain speculative, they underscore the profound gaps in our understanding of the planet's atmospheric mechanics. Observations over the years have revealed another layer of mystery: the storm's dark coloration. Unlike the bright methane clouds that dominate Neptune's atmosphere, the dark spots absorb sunlight, creating an ominous visual contrast. The origin of this darkness is not fully understood. Some hypotheses suggest it results from unknown compounds or aerosols formed high in the atmosphere, perhaps altered by ultraviolet radiation or chemical reactions driven by the planet's extreme environment. Yet, the exact composition and why it fades as the spots disappear remains unresolved. The vanishing of Neptune's dark spots serves as a humbling reminder of the limits of human knowledge, even when studying planets within our own solar system. They appear suddenly, dominate the planet's visage, and then vanish, leaving only faint traces of their passage. Each disappearance challenges assumptions about atmospheric stability and raises fundamental questions about the forces shaping planetary weather. In the case of Neptune, observation is a delicate dance of patience and serendipity, for we see only fleeting glimpses of its dynamic, ever-changing skies. As scientists continue to monitor Neptune with telescopes and plan future missions, the planet's vanishing storms invite reflection. What other transient phenomena lie hidden in distant worlds, shaping environments beyond our comprehension? Could there be rhythms, cycles, or forces that govern their appearance and disappearance, or do these storms emerge as spontaneous anomalies in a turbulent system we have barely begun to understand? Neptune's dark spots, enigmatic and ephemeral, drift silently across a distant, frozen world, a reminder that even in our celestial backyard, mysteries endure, waiting for patient observers to trace their fleeting signatures and decipher the hidden patterns of a universe far stranger than we often imagine. Drifting silently in the outer reaches of the solar system, Uranus presents itself as a serene, pale blue orb, its atmosphere a delicate blend of hydrogen, helium, and methane. Yet beneath this calm veneer lies a planetary oddity that has puzzled astronomers for centuries. Uranus rotates almost entirely on its side, with an axial tilt of approximately 98 degrees. Unlike any other planet in our solar system, Uranus seems to roll along its orbit like a cosmic barrel, a world in perpetual sideways motion that challenges our understanding of planetary formation and dynamics. This extreme tilt was first hinted at in the 18th century when astronomers charted the planet's faint rings and subtle cloud bands. But it was the observations of its rotational axis and seasonal cycles that revealed the astonishing reality. Each Uranian pole experiences decades of continuous sunlight, followed by equally long stretches of darkness, creating seasons that span over 20 years. How could a planet arrive at such an unusual orientation? Mainstream theories suggest that a colossal impact with an Earth-sized protoplanet early in Uranus's history may have knocked it onto its side. But even this explanation leaves questions unanswered. Could a single collision account for the planet's remarkably regular orbit, its intact moons, and the precise alignment of its rings? Or might there be subtler forces at work, hidden in the mechanics of the early solar system? The implications of Uranus's tilt extend far beyond mere curiosity. The planet's peculiar rotation affects its atmospheric dynamics in ways that are difficult to fully model. Winds on Uranus can reach hundreds of kilometers per hour, but their patterns defy simple categorization. Storms and cloud formations drift along unusual paths, responding to a rotation that places equatorial and polar regions in positions unfamiliar to those of Earth or even its neighboring giant, Neptune. Scientists studying the planet must grapple with these alien conditions, attempting to understand how energy, heat, and weather systems behave on a world turned sideways. Yet the mystery deepens when considering Uranus's moons and ring system. The planet's satellites orbit in near-perfect alignment with its equator, which itself is tilted almost perpendicular to its orbital plane. How did these moons survive, or perhaps form, after such a dramatic event? Did the tilt occur before or after the formation of the satellite system? Could gravitational interactions with other planets or the Sun have influenced the axis over millions of years, subtly nudging it into its current position? Each hypothesis provides partial insight, but fails to fully reconcile the planet's observed structure with the violent history implied by its tilt. Some speculative theories have ventured further, suggesting that Uranus's rotation might be the product of multiple smaller collisions or cumulative gravitational torques exerted during the chaotic early stages of the solar system. Others propose interactions with yet undetected planetary mass objects, or even the influence of dark matter distributions within the solar neighborhood, a subtle cosmic hand slowly tipping the planet over eons. While these ideas are more conjectural, they highlight the gaps in our knowledge and the depth of the mystery surrounding Uranus's unusual orientation. Observational data, limited by distance and technology, continues to fuel the enigma. Voyager 2's brief flyby in 1986 provided unprecedented glimpses of Uranus's rings, moons, and cloud structures, yet left astronomers with more questions than answers. Subsequent telescopic observations, including those from the Hubble Space Telescope, have refined measurements of axial tilt, wind patterns, and seasonal changes. But the origin story of this sideways world remains elusive. How does a planet achieve such a tilt while maintaining orbital stability and a relatively undisturbed system of satellites? And why does Uranus appear so distinct from its similarly sized sibling, Neptune, which exhibits a more conventional rotation? The sideways spin of Uranus also challenges our broader understanding of planetary formation. In most models, planets form from rotating disks of gas and dust, naturally inheriting a rotation roughly aligned with their orbital plane. Uranus defies this expectation, a celestial outlier that forces scientists to reconsider the role of chaotic impacts, migration, and gravitational interactions in shaping planetary systems. Could there be other worlds, both within and beyond our solar system, whose histories are equally violent or peculiar, their tilts and spins hiding untold stories of cosmic collisions and reshaped orbits? As researchers continue to observe Uranus and develop increasingly sophisticated simulations, the planet remains a profound reminder of the universe's capacity for surprise. Its axial tilt is not merely an oddity. It is a window into the processes that govern planetary evolution, a puzzle that blends physics, history, and the deep, often violent choreography of the early solar system. Each calculation, each observation, draws us closer to understanding. But the more we learn, the more we confront the mysteries that remain. Uranus rolls through space, a silent testament to the forces that shape worlds. Its sideways journey raises questions not only about its own past, but about the nature of planetary systems, the scale of cosmic collisions, and the unexpected ways that matter and energy can conspire to produce something utterly extraordinary. The answers are out there, embedded in the pale blue clouds and icy rings, waiting for patient eyes to uncover the secrets of a planet that refuses to follow the rules we thought were universal. Drifting across the vast expanse of the cosmos, we encounter a puzzle written in the very fabric of the universe. Among the countless elements forged in the crucibles of stars and the aftermath of the Big Bang, one substance has proven particularly elusive: lithium. It is a humble element, scarcely more than a trace of cosmic matter, yet its apparent scarcity challenges our understanding of astrophysics and cosmology. Observations of ancient stars reveal a puzzling deficit, a missing lithium that theoretical models insist should be far more abundant. Why, after billions of years of stellar alchemy and cosmic evolution, does lithium seem to have vanished from the cosmos in quantities we can detect? The story begins in the earliest moments of the universe, during Big Bang nucleosynthesis, the first few minutes after time itself began. Hydrogen, helium, and a small amount of lithium were created in precise ratios predicted by theory. These ratios, tested against modern observations of the oldest stars, align remarkably well for hydrogen and helium, confirming our understanding of the primordial universe. Yet lithium tells a different story. Ancient halo stars, relics of the early galaxy, contain only about a third of the lithium predicted by our calculations. How could such a discrepancy persist across billions of years? Could this be a failure of observation, a limitation of our instruments, or does it hint at deeper, unresolved phenomena? Mainstream astrophysics offers some explanations, though each raises further questions. Some propose that lithium is destroyed within stars over time, burned away in processes that convert it to heavier elements. Others suggest that stellar interiors might be more turbulent than models assume, allowing lithium to sink and disappear from detectable layers. Yet these explanations are incomplete, failing to account fully for the levels observed in the most ancient metal-poor stars. If stellar destruction were the sole mechanism, why do some stars retain more lithium than others under seemingly identical conditions? The enigma deepens when we consider the broader cosmos. Measurements of lithium in interstellar gas, in distant galaxies, and in cosmic clouds consistently show a shortage relative to theoretical expectations. This is not a problem confined to a single star or region. It is universal, a discrepancy spanning space and time. Could the universe itself be hiding lithium in forms we cannot yet detect? Are there processes in the early galaxy, or perhaps in the chaotic interactions of stars and supernovae, that siphon lithium away from the visible universe? Or might we be witnessing evidence of physics beyond the standard models, subtle forces or interactions that subtly alter elemental abundances across cosmic scales? Some speculative hypotheses venture even further. Could lithium have been destroyed by exotic particles or early cosmic phenomena no longer present? Is it possible that our understanding of nuclear reactions in the first stars is incomplete? That unknown mechanisms altered the initial abundance of lithium in ways we cannot yet replicate in the laboratory? These ideas push the boundary between established science and theoretical exploration, reminding us that the universe often holds more questions than answers. Observational astronomy continues to probe the puzzle. High-resolution spectroscopy of ancient stars, combined with sophisticated models of stellar evolution, has refined our measurements of lithium, confirming the deficit with ever-increasing precision. Yet even with the most advanced telescopes and computational models, the missing lithium remains an enduring mystery. Each observation seems to deepen the enigma, revealing patterns and anomalies that resist simple explanation. The universe's silence on this element is as intriguing as it is frustrating, inviting scientists to look not only at the stars themselves, but at the underlying assumptions about how matter behaves on cosmic scales. Lithium's absence resonates beyond the laboratory or the observatory. It touches upon fundamental questions about the origin and evolution of the cosmos. If our understanding of Big Bang nucleosynthesis is incomplete, what other aspects of cosmic history might require revision? Could there be hidden reservoirs of matter or subtle physical processes that have quietly shaped the chemical composition of galaxies for eons? And if so, what does that tell us about the limits of human observation, the unseen mechanisms guiding the universe, and the mysteries that lie beyond our current reach? As we trace the faint traces of lithium in stars both near and far, we are reminded that the cosmos is not merely a backdrop for human curiosity, but a vast, intricate system full of puzzles that defy simple solutions. The missing lithium is more than an absence. It is a whisper from the universe, a subtle clue that hints at unseen forces, unknown histories, and cosmic events that remain just beyond our comprehension. In the quiet glow of ancient stars, the universe invites us to ponder. What else lies hidden, waiting to be discovered, in the delicate balance of matter and energy that has shaped everything we know?